work. Thank you. Thank you for letting me know. And the very design, economics, and business models, I believe, is going to change. Now, let me explain. I am going to put it down to 8 important areas. What is the climate affecting? One is obviously we know what fragment is small holding, extreme weather and machine durability, water scarcity and precision agriculture, labor migration, mechanization pressure, energy transition and decarbonization, supply chain vulnerability, carbon accounting and sustainability pressure, digital divide. I mean, these are all negatives I can talking about. I mean, you can look at it as negative, but is there any strategic opportunity in all these things? And what is a larger reflection? And how do we actually cross this barrier? Let me take one by one. This is probably very typical for Asian agriculture, because Asian agriculture is dominated by small and marginal farmers. We come from India. We're really talking about what 85% of our thing is less than a hectare. So it's a very different ball game compared to what has been happening in Europe. And what happens in this case is the farmers are actually led to much more volatility with respect to climate, because it is not a question of irregular monsoon. It is a question we don't know when the monsoon is going to fall. If you're going to tell me that monsoon is to come in April, now it's going to go to May, I'm prepared. But if I don't know what is going to happen, whether the April monsoon is going to be the way the April monsoon is going to completely pour down or not pour down, that is the issue. And even today, this year, we are talking El Nino, the same problem. Clarity is not there, and that is a big problem as far as the farmers are concerned. And of course, associated with this, the droughts and floods. And you can see that the drought, flood, and is actually been increasing in this part of the world. And we have been seeing it, we have been hearing the news. Now, what happens when this happens? Traditional large tractors equipment often become, now that is a very interesting thing. See, imagine that I am really building my agriculture with very large tractors and equipment. There is a very good possibility that this may not be more viable. Now, let me explain why they will not be viable in the subsequent slides. Actually, what is happening is the direction I think we'll be going is this is going to create a lot of pressure on manufacturers to develop. Now, I'm going to call it small and modular machines. I'm going to call it a multi-purpose equipment and affordable autonomous systems. And everything has got a meaning. When I say affordable, I genuinely mean it is affordable. And shared use or rental-based mechanization model and small is scalable is going to probably be the way we are going to look at the world. Now, why do I say small modular machines? Or let me club these two, multi-purpose and small and modular. See, if I'm going to make a very specific equipment only for agriculture, see, one of the reasons Indian tractors do well is because little part is agriculture, the rest is so many other operations. But if I start making specialized machines, believe me, if somebody is going to buy it and he's going to only use for a window of 14 days, or 2 seasons, got a window of 28 days, that machines may not be, how do I say, you may not be able to get the best value of the machine. The cost of the machine is going to be so high, and we are not able to optimally use it. You're really going to put the farmers into trouble. So we're really looking at small and modular machine. And when I say affordable autonomous system is, I don't think many of the countries today, our population is not a problem. So that I don't think we'll be going totally autonomous. But we will be looking for something which is a little semi-autonomous, which can enable the driver to be a little more relaxed. All is difficult things taken over by the autonomous system, but he's still available on the tractor or on the equipment or monitoring an equipment. Now, why monitoring? I'll come back again. The next is, of course, this is a discussion I always have when it comes to, I think Dr. Indramani knows about it, that when we talk about emission in India, one of the biggest problem is, it's all great to talk about emission, but we are going to try to put things in very small tractors. We are going to push to Euro 5 or Euro 6. The issue is, how are you going to manage it? It's an open equipment. It's not like an automotive where everything is exposed to the vagaries. So when you have paddy fields, flooded paddy fields, and some of you know, both in Thailand as well as in India, we really put the tractor, half the tractor gets immersed in the water. And imagine what happens to a sensor system in such a situation. So we need to have something which will work. Then, of course, salinity intrusion is problematic in both, not only for the soil, also for the equipment. It is both. I mean, we always talk about salinity, you only link it up with the soil, but it's extremely bad for the equipment. then you may have differences in ambient temperature. Today we are talking about what? 47 degrees in India in certain places. And just imagine something you need to work at that temperature also need to. So the question is, are you going to design an equipment which can take care of all this? Or are you going to have different equipments to take care of all this? We really don't know. I'm not giving a solution here, but I think this is something the manufacturer need to think through. Then equipment designed to stable climate, that's another problem. If you try to take care of everything, it may be an underperforming with respect to agriculture, which is also not acceptable for the farmer. He immediately rejects the equipment. So manufacture, the way I look at from manufacturing point of view is we need to really start looking at climate resilient mission. In India, interestingly, some people who come from our area, we know that we may have some 15 or 16 varieties of the same machine because we're going to work in different places in India. Small modifications, but that is needed. So this may be one way of looking at it. Then, of course, corrosion resistant system is going to be very important if you really are going to get into salinity areas and you're going to have very varying temperatures. The temperature actually really badly affects the way things corrode. Then is, of course, heat tolerant engines and electronics. This is another question people ask for. We used to have a water cooled engine and we also have air cooled engines. I don't know how many of you really know that sometimes the air cooled engines are preferred in deserts because you don't not depend on water at all. The engine is designed to take up that kind of. So you have to really start thinking: am I optimizing with a water cooled engine when water itself can be a problem, or should I go for something which can work in a very high temperature situation? Of course, then precision and farming component. I'm going to skip. I think because somebody is going to put pressure on my timing, so I'm going to really run. Thank you. Yeah, people sitting back. I know. So, of course, we talk about water stress. So basically, I think this is an area which I have been talking about. Today, everybody talks about, I am putting 5 kilowatts per acre. I'm putting 10 kilowatts per acre. Are you going to measure what you are going to put as a power per acre? Or are you going to say that per kilowatt, I'm able to do the maximum production? Per kilowatt, I'm able to get the maximum water saving? That's the way we need to look at it. I think this is one area I've been fighting with some of the European fellows saying that don't come and talk to me on kilowatts per acre, because that's losing sense because you went up on the horsepower, so it made convenient to talk about it, but not in our case. So what will be our demand? I think we will be genuinely going for everything that can save money for the farmer, whether it's in the form of seeds, fertilizers, pesticides, water. It also can be preservation of soil and also lowest power. So you're really talking about precision seeding systems, smart irrigation system, variable rate applicators, air-driven spraying systems, and also soil moisture linked implement. I know soil moisture linked implements is a little bit of a ticklish area, but what I'm trying to say here is I don't need, yesterday we were discussing with somebody that if I have to do one furrow, gentlemen, I need 10 horsepower. With the 10 horsepower, I can do a furrow comfortably. So if I got a 50 horsepower tractor, I can happily do 5 furrows without any problem. If I have a 500 horsepower tractor, probably I multiply by 10, I can do so many furrows. But then in order to support system, the entire weight of the tractor goes up. So it's not a proportional weight going up. It is tremendously the weight goes up and you are actually moving a lot of mass and you are consuming a lot of diesel. Or a lot of power is wasted another way. So that is another question we have to look at here. Then the biggest problem I think is going to have everywhere is when the climate changes, you are going to face the rural migration. I don't have a choice because the people think that that's 10 minutes. Yes. Good. Thank you for reminding me. So I think what we are going to happen is when you talk about rural migration, young people whom you cannot tell them, gentlemen, you will start making some money every month. Tell me how many of you like to work somewhere with a promise that every 6 months you will make some money. I won't work. I'm sure younger people won't work. So you really need to make some money every month. So that is a thought process they have. That is where we need to really help in agriculture. So autonomous equipment, certain areas, yes, but I think I will go with semi-autonomous equipments and implements as far as Asia is concerned. Drone-assisted farming, swarm robotics is a favorite topic. And this is where I think the entire Asia is going to change. Rather than making one large tractor, today we have an ability to make maybe a 50 horsepower tractor, swarming it up so that 10 of them can become a 500 horsepower tractor. If you want, one man can control it or nobody need to control it. In Asia, I say one man will control it and he will ensure that small farms, large farms, everything can be done. But more important, everything is going to be that we need to have agriculture as service, because I don't think farmers will be able to buy equipments as things go by. So we really need to look at it as, then of course, the other area I think we'll be developing, and I think we are all, this is one area we are definitely developing. We are looking at hybrid, electric, hybrid, biofuel compatibility in hydrogen. I think biofuel, India is now going to 85% of biofuel. I don't know how many people have seen that announcement. Within a year, we are looking at 85%. And hydrogen experimentation, we are all started. Then solar powered farm equipment. Recently, there was an announcement that today we have a car in India which works completely on solar power, and it is priced at $3,000. So that is something I think we need to really look at. Very small equipments like weeders can happily work on a solar power, because all of us. Thank you for reminding me to get out. So I think I'm going to really go to the last slide. This also I'm going to leave it. Okay. So where are we leading? I think let me read the last slide. The technology what you're looking at has to be affordable, and gentlemen, it has to be repairable. Because I think without in Asian mentality, anything which is not repairable, it may not be workable. And a lot of things has to be in local dialect, because many times you are going to get the first generation of digital farmers trying to use it, so it has to be meaningful. And I still believe that while Asia can be a global hub, smallholder innovation, because we focus on frugal engineering, then we also think that we may be able to get future may not belong to the bigger tractor, but belong to compact, connected, climate aware, collaborative work as for equipment, not only tractors, even equipments. So there, I think I come to the stop, sort of managed to push it through. I know this is a large topic, so we can talk forever. Thank you.
Well, thank you for the nice presentation and for excellently keeping the time. I think I was asked to give the certificate of appreciation to you. So
I don't find my questions for them that way. Yes, you. Thank you. Just one second. One more. Thank you. Is it okay?
yeah,
Can I use this?
Yeah, sure. Please. So the next presentation will be given by Professor Mehari Takesti. Sorry if I pronounce it wrong, from Iowa State University. And the presentation will be on mechanization challenges, considering crop productivity and climate resilient soil conservation systems. So the floor is yours, sir.
All right, thank you very much for inviting me to give a talk. And I will give a talk on mechanization challenges considering crop productivity, climate resilient soil conservation systems. I'll try to give a brief introduction, and then I will give where I see the advantage or the ability. Can you hear me? Yeah. The opportunities to bring digital twins into mechanization and resilience of the soil ecosystems. If time allows, I'll bring a topic on lessons, what we learned from the US or advanced economic crop production systems. I am from Iowa State. We have a group. We are called Soil Machine Dynamics Laboratory. I just share this because sometimes, students who might be interested to do graduate study in our program, you're most welcome to connect with me. In our lab, we have equipments that would measure single tire tester, wear of ground engaging tools, and then simulated scaling laws of ground engaging equipments. Why we use this and how this lab is becoming useful is really to validate models. when you do physics-based simulation, you have to validate it, and we leverage our laboratory system for that. A lot of applications that the lab is useful is, our soil is artificial soil. It does not have water on it. It gives a lot of repeatability of systems like tire or ground engaging tools. This is just an example of our results, what we've been doing. I think the main takeaway that I want to bring in this talk is how do we bring soil model or crop model into an engineering workflow earlier, so one, you could accelerate the design process and also reduce the cost of iron and physical prototyping by leveraging digital twins. Similar to the soil part, our group also work on grain or husk type systems. Now, what do we learn about this mechanization programs in a lot of this rapidly growing economies is, I will just bring examples from Africa or Asia. There's really a rapid trend of mechanization over the last 20 years. Anytime that mechanization comes into the field, because there's machine, there's iron, most machines that we know are 2-axle wheels, and they're designed by 3 things. They have size that needs to fit onto the road. They have weight. Part of that weight is designed to deliver power. So if you see any tractor or any machine out in the field doing soil work, at least it will deliver 50% of its weight for power. So it's really, we're bringing iron to an axle, a system like that. Now, in that system, how do we address sustainable agriculture where we need a feed, bring fibers to the table or energy, and we should remember that we live on the soil. Inputs, agricultural inputs such as fertilizers, seeds, pesticides, to me, they're just commodity, they come and go. Soil will stay there. We need to reserve our soil anytime that we do production system. This is really a good example where this is close to 8,000-pound tire rolling on a corn at V4, and the corn was not broken, okay? So this wheel was full tanker of planter for 24 row, went over the corn, and it did not break it, okay? This is not animation, this is real. What do I mean by that is, if we bring low ground pressure systems into our soil, we would preserve our soil. Another part is anytime that there is mechanization process, it's a system based. So we need to think about this machines be part of the ecosystem. At the end, there has to be economic viability. At the same time, resilience, giving that land for the next generations. A few backgrounds. I think most of us are aware of this. A lot of, in the growing economy, population in the farming ranges from 60 to 90 in some African countries, 30 to 75 in the Southeast Asia. Agriculture is very important. It accounts significant portion of the GDP. But what we have noticed from a lot of literature is this key point. Agricultural extension research always show a higher yield than what a small farmer harvests in the field, okay? Yeah, there are a lot of differences between that, but what we have learned is it's almost 4 times what a small-scale farmer can harvest. So I'm not saying we should achieve that. What I'm suggesting is we should target a portion of it to bring it to the small-scale farmer. Is it 100%? Maybe not. But if we aim a certain percentage, I think we become very practical. I read a lot of articles, and we'll put this into this publication. I think there's this very good study by Brown. They did a survey, and pay attention on here. That's where I will bring that, the key indicators of soil and crop systems. From their study, about 500 farmers, I believe, the highly adopted systems is four-wheel drive, not two-wheel drive, okay? Four-wheel drive delivers more traction at the ground than two-wheel drive. In other words, two-wheel drives might be cheaper, but in the long term, they will consume more fuel as compared to the four-wheel drive. Another one that was rated high is rotary tiller. I came here on Monday. I was at the show. I spent most of my time to learn about this system because I did not grow up in this system. Why is this rotary tiller so popular? It's becoming part of the mechanization. For those farmers or researchers in Asia, that might be a typical or a very common knowledge, but that's what they also farmers adopted as part of a big grants from USDA and others. The one that I want to highlight is this one, zero-till drill, okay? In other words, if you bring technologies to the farm that does not adapt to the agroecological system of what a farmer would look at its conventional or typical cultural practices, they don't adopt it. We have seen it in the U.S. So if you see U.S. from 1990s all the way to the 2000s, we have seen a rapid increase in no-till systems, okay? From 2000s up to now, what we have seen the no-till systems is it plateaued, okay? It did not increase. What is increasing in the US is reduced tillage or minimum tillage systems. So in other words, there are ecosystems that know the value of no-till system, they adopt it, and they keep it. In Asia, in this study, they were identifying that as no adoption. Part of it is there was lack of knowledge on how to do those systems, which the complexity of it is coming from the soil or the crop residue management, financially and other aspects. I'll stop, I'll go through fast on this. This is just the statistical data, but there are key indicators on this. So this is from FAO and World Bank on number of tractors in thousands in 1990 and 2013 on a four-wheel drive. There was really an increase in the range of almost 6 to 7 times higher, with most of it, Vietnam had shown like 33 times more four-wheel drive in the market, okay? This is statistics published by that article. This is also the same in a lot of African countries from FAO. I think there are countries in this cluster. This is from 2000 or 2005. Maybe they are in this range, okay? And I don't know about this. They're talking about this in millions. What this shows is looking at the numbers. The tractor units, which is the powerhouse of farming, is continuously increasing in Africa and Asia. Now, if we look at yield is increasing, machinery are increasing, there's also another interesting trend. I think I heard the voice. There's also another interesting trend, which if you see any yield increase, there is exponential relationship with how much kg per hectare you're bringing urea to the field. If you pump urea to the field, I think you might get a good yield. The economics of it may not always be justified, okay? So trends is increasing fertilizer rate, increasing mechanization gives more yield. So linear thinking, right? Now, but if you look at the cereal crops, US versus the sample examples of 3 countries, it's very interesting. So US have seen an increase in crop yield of an average aggregated 38%. The sample countries also show 25%. So it's really good, I think, the trend in terms of productivity. What I want to highlight is in the US system, okay, from after Second World War, what we have seen is an increase about 1.9 bushels per acre per year increase in corn yield. There's a statistics data from Purdue. At the same time, the weight of tractors unballasted from Nebraska tractor test that we're putting together a publication from 1921. After 1960, I mentioned the yield is 1.9 bushels per acre per year. Tractor weight was 456 pounds per year. They're very parallel, but more machines' weight is coming to the field. What that means is more compaction from those heavier machines. Now, the yield increase can be explained partly by genetics, okay? Partly you saw that, pumping fertilizers or chemical applications. But I think in the rapidly growing economies, Asia and Africa, I think we need to do more on this. What do we mean by mechanization? Does the number of tractors justify that? Or is there a performance measurement that we need to do? How do we bring the soil resources into the equation such that we do not want to degrade our soil resources? When it comes to any system, there is a part that has to be done is how are we doing soil conservation system in any mechanization process? We should not think linearly, machine is weight, iron, and power, but there is a soil resource. A good report that was published from Nebraska Tractor. Sorry, I don't know. I could stop anytime. Is when you look at corn yield, okay, in a no-till system, what I want to highlight is when there's crop rotation, okay, comparing yield of corn in a crop rotation, corn, oats, sorghum, and soybean versus only corn and corn, there's 5 times yield increase. Okay, so crop rotation is really essential. I'll stop here and then I'll have any questions if you have any. The point what I'm saying is I brought up about the virtual digital twins. We have an opportunity to bring simulation and modeling in the early or later parts of that to select the right machine forms to conserve our soil resources, mainly soil compaction, by looking at low ground pressure tires or radial tires instead of bias ply tires, or VF or IF tire inflation pressures. You could do all those in the simulation, and I'll stop here. Okay?
Thank
Gosh,
you.
it's a rush. I haven't run for a while, but this is a good run.
Yeah. Thank you very much. And I think there's still so many things that we can do to improve mechanization.
So, you can share your slide with the participant.
All right.
Just I want to look at the cover. Don't worry first. Thank you.
Thank you. All right.
All right. All right. So the next presentation will be given by Dr. Jeet Chan, who is the president of the Nepali Society of Agricultural Engineers. Just a second.
Hello.
Yeah. And his presentation will be on climate change science and key concept of management, adaptation, and mitigation, with a focus on water and agricultural sector in Nepal. อันนี้ไม่ใช่ฮะพี่เดี๋ยวนั่นของเขาเดี๋ยวไปชม You want to take it back?
No, that's fine. I can wait, but I want to make sure. Okay.
มาแล้วพี่มันแวบๆอยู่ข้างล่าง
Good morning and namaste everyone. Because of time limitations, although there are many slides, I will try to finish within time. And for that, I will particularly focus on climate change issues in Nepal and how Ministry of Agriculture and Livestock Development and particularly agricultural engineering initiatives are applied in Nepal's agriculture and water sector to cope the adverse effects of climate change and to trap some opportunities of those climate change effects. My presentation will be focused, I already told, about Nepal, river basin system, climate change and Nepalese agriculture, adaptation and mitigation and key adaptation practices, engineering perspectives. I will not go more detail about the science of climate change. It's we all throughout the world, we are facing some adverse effects of climate change, and particularly agriculture, water sectors, forestry, health, and ecosystem biodiversities are hardest hit sectors from adverse effects of climate change, not only in Nepal, I think throughout the world. Nepal is an agricultural country, small agricultural country, and nearly 3.5 million hectare agricultural land, 2.5 million hectare irrigable land, and so far about 64% area is irrigated, and with 36% year-round irrigation and efficiency 30%. Nepal has tremendous amount of surface water availability, 225 billion cubic meter annual, groundwater 13, and used percentage is only 17 BCM. 96% water is used in agriculture, 3.7% for domestic, and only 0.3% for industry. Per capita annual water availability in Nepal is 7,000 cubic meter, and average annual rainfall 1,500 mm, which is significantly higher than world average, around 800 mm. Nepal has above 6,000 river systems, large, medium, and small rivers, and they all rivers eventually drain into the Ganges river basin. Large rivers contribute 78% in annual flow. Medium rivers, they originate from Mahabharat range, they contribute 9%, and small rivers, they contribute 13% in total flow. And Nepalese rivers are the primarily lifeblood of the Ganges river basin, providing roughly 40%, above 40% of the Ganges total annual flow, and up to 71% during the dry season flow. In media also, we have seen lots of issues about climate change, their effect in agriculture and other sectors in Nepal. Recently, I think 10 or 15 days ago, ICIMOD has published one good report about how quantity of snow is decreasing in Hindu Kush Himalaya. And then our very popular online media, Kantipur, they published how winter rainfall is decreasing in Nepal every year. Around 60 mm is average annual winter rainfall in Nepal, and in last 6 years, the amount is significantly decreased, and we are facing water challenges in irrigation sector for winter crops. The major effects of climate change in Nepal are glacial retreat. Nepal's glaciers, including those in the Himalayas, are melting at an accelerated rate, leading to the formation of glacial lakes and increased risk of glow. Nepal's glaciers are shrinking by about 0.6% per year. In the Everest regions, glaciers are retreating at a rate of 10 to 60 meters per year. And natural hazards, globes-related natural hazards are 25 events in last 70 years. Changes in precipitation pattern. As we all know that shifts in rainfall patterns, amount, timing, intensity, distribution, and they are severely leading to increased frequency and severity of floods and landslides. And last year in the monsoon season, paddy growing season, there was big challenges. There was no rainfall in our paddy growing season, and farmers were facing extremely challenges in that time. Changes in temperature. Temperature increase in Nepal 0.06 degrees centigrade to 0.12 degrees centigrade per year in most of the middle mountain in Himalayan range, and less than 0.03 degrees centigrade in Siwalik and Tarai region. increased frequency of extreme weather events. Last year and in 2025 also, there was severe flooding in Nepal. Even in Kathmandu Valley, we didn't see such type of massive floods in Kathmandu Valley. In other areas also, there were tremendous floods and huge losses of agricultural area, properties, and lives. In 2024, September 26 to 28 event, loss in agriculture sector was 40 million, and our thousands of agricultural land become, this type of, we lost our paddy field, we lost many fisheries ponds and many standing crops in that time. Overall impact of CC in Nepal, if this type of adverse effects of climate change happens and we will not manage those to a level, then there will be around 13% GDP loss by 2100 and 1.5 to 2% GDP loss that is categorically defined here. We also studied how climate change is affecting in irrigation system and irrigation command area that is published. Me and my one student studied this in Chandra Canal irrigation system, the oldest irrigation canal of Nepal. Mitigation and adaptation. Since last 10 to 15 years, mitigation and adaptation in terms of plan, policies, projects, even in our project, Prime Minister Agriculture Modernization Project, there our one of the biggest, largest strategy is climate resilient agriculture and climate smart agriculture, adoption and application to farm level. Key national commitment and plan in mitigation, we have two second nationally determined contribution NDC and Nepal's long-term strategy to net zero emission, and adaptation, vulnerability and risk assessment and identifying adaptation options. Government of Nepal National Adaptation Plan, NAPA and LAPA is also there, and there are now in any project in Ministry of Agriculture, Ministry of Forest, Ministry of Water Resources and Irrigation, climate smart agriculture and climate resilient systems are highly prioritized. And what we are doing, particularly I am focusing what agricultural engineering discipline is doing to cope these effects in Nepalese agricultural system. We are trying to focus, we are trying to extend climate smart agricultural system at local level. What is climate smart agriculture? Higher productivity, adaptation, and mitigation. First, we are doing to extend climate smart agriculture is greenhouse based production system, also called facility agriculture. There are many greenhouses, plastic tunnels, low cost to high cost, low tunnel, bamboo tunnel to automation system. We are establishing many greenhouses production system throughout the country, particularly in Mid-Hill and Tarai. These are some photos we have developed at farm level. And then precision agriculture. Now precision agriculture is also gaining momentum in Nepal. We are using drone, not throughout the country, but in some specific area, we are also using agricultural drone to apply insecticides, pesticides, and other micronutrients. Resource conservation technologies, although it is not in big level, but resource conservation technologies, our cities are also implementing laser controlled land labeling, zero tillage, minimum tillage. Those type of technologies are used by farmers. And agricultural mechanization and automation. Now the government of Nepal's, particularly Ministry of Agriculture and Livestock Development, biggest strategy is agricultural mechanization followed by automation. We are doing now, I think in rice, wheat, and maize, around 95% mechanization is possible. Not only, not in all the farmers level, but commercial farmers, they are using mechanization up to 95%. And these are some pictures our organization is doing throughout the country in how mechanization is working there. And because of mechanization, input production cost is reduced by around 30% and lots of drudgery reduction, grain and food quality improvement, time, accuracy, and other things are improving in Nepalese agriculture. And agricultural mechanization services, it guided by custom hiring center. Now this custom hiring center establishment is getting popular in Nepal. Nearly 600 custom hiring centers are established by our organization, Prime Minister Agriculture Modernization Project. And now local level, they are also establishing custom hiring center on 50% government subsidy and 50% users committee, cooperatives and private group. These are some photos. We are extending technology in large plot also for maize super zone. Now, how Nepalese agriculture is transforming, particularly in woman-friendly agricultural mechanization in Nepal. Before, women used manual tools, power-intensive tools. Now they are using small but mechanical power in their farm so that their drudgery has been reduced. These are also the photos. Now, Nepal's agriculture depends on women and elderly people, and this type of mechanization services has helped a lot. Mechanized dry DSR, we are also, now this year also we are focusing mechanized dry DSR in our Madhesh region. Contour and terrace farming, these are some photos. Our organization is doing contour and terrace farming in mid-hill Nepal. Micro irrigation is also getting momentum, and we are also promoting micro irrigation, particularly drip and sprinkler irrigation at commercial farms, and almost in all the greenhouse based production system, we are giving micro irrigation system there. Water delivery and field channels, irrigation management is very important from climate change point of view. We are focusing on water delivery and making field channels at farm level so that application efficiency will be higher. No,
Press the wrong button.
no.
Press this.
Okay. This is irrigation management. How we last year, what type of problems our Madhesh province farmers faced in the paddy growing time, and we have recommended some strategies how we can cope those type of adverse effects from climate change. I will not go too long. And in my conclusion, Nepal, water resource, agriculture, forestry, and health are the hardest hit sectors. And sustainable use of input resource, technology agriculture, intelligent fertigation, greenhouse-based farming, irrigation management, and IPM field schools are some key strategies for climate smart and climate resilient agriculture production in Nepal. Coordinated effort from government, private sector, academia, research, farming community, and non-government is needed for effective climate change management. At last but not least, nothing goes right if agriculture goes wrong. Agriculture can't go right if engineering goes wrong, because modern agriculture is engineered agriculture. We are focusing more on engineered agriculture, technology agriculture to cope, to manage some adverse effects of climate change at farm level. Thank you.
Thank you.
Thank you.
So the next presentation will be given by Dr. Mukund Babel. Is he here?
Yes.
All right, please. And the presentation will be on climate resilient agriculture in Asia, adaptation planning for an uncertain future. So, floor is yours, sir.
Thank you very much. I hope it works. Okay, thank you very much and good morning. 10, 12 minutes, right? So let's start with, I'm trying to give you a concept which you may like to explore further, and trying to give you a quick application of that concept which we have been working on. For last about 2 decades or so, my work is more on climate and water, and of course agriculture cannot be escaped. So climate, water and agriculture, and we recently established a center which is called Center for Water and Climate Adaptation at Asian Institute of Technology. Some of you visited yesterday our institute. So I'll try to speak on how do we come up with climate resilient agriculture in Asia? How do we adapt? Basically, how do we increase the resilience in uncertain future? So this is the main point which we should try to understand. And I start with a quote, a philosophical quote that known knowns, known unknowns, and unknown unknowns. And I would not spend more time on it. You all will know this. Where are we in terms of when it comes to climate change? Jeet has given a good kind of a good background, so it would help me not spending much time on background. But I would like to introduce you what we call top-down and bottom approach and CREDA approach. That's the point which like to emphasize on. And probably this is the study which was done by one of my PhD student is the first application of this climate risk informed decision analysis to agriculture sector. I was part of this development of this approach. Just to give you only one slide on why there is a need to adapt and why there is a need to improve the resilience of agriculture sector in Asia. You see here how the situation of rice. Again, rice is a main crop, and what would be the impact by 2030 and 2050, and what is the negative impact in terms of GDP, which is what is explained here. Very briefly, look at, and this is rice bread basket, which is China, India, Indonesia, Bangladesh, Vietnam, right? Main rice growing countries, and how they will be impacted by 2050. And the main point here, again, repeating what I said earlier, uncertain future. Within that uncertain future of climate, how things are going to change is quite uncertain. So, and if we don't adapt, then there is a risk of about 25% of harvest being, and it would lead to food insecurity. Now, the typical approach which was followed in the past and still followed in many places is a top-down approach where you start with looking at what the future is going to be in terms of what are the GHG emissions going to be, how the climate is going to change. And we use a lot of modeling here, right? And which I also worked on this top-down approach for 15, 20 years since 2000, early 2000. But then we come up with uncertainties. The envelope of uncertainty increases. So we need to move and think of something else. And this is how this bottom-up approach has come up. And uncertainty is there. Uncertain future is there. But what is certain is that what is the current situation? Where are the tipping points? Where do we say that system is going to fail? Right? With that, this is the kind of approach. So the approach, there are 5 steps, and I like you to try to understand that. Number 1 is decision context, understanding the problem. And most of the time we don't understand the problem. And if we understand the problem, we find the solution, which is going to be a problem tomorrow. So solution is today, problem is tomorrow. And then again, so that is very important here. Understanding stakeholder engagement is the key here. Try to come up with a performance metrics. How do we want to compare? How do we want to test? And identifying what are the key stressors. And those key stressors could be climate stressors, could be non-climatic stressors. And then we look at the bottom-up vulnerability assessment, and there could, again, you may be using some modeling tools because of the system, understanding the system, right? We try to do what we call stress test, and most of you are working in mechanization. You know what is a stress test, right? Where the machine fails, and here the system fails, right? And then come up with the formulating robust and flexible actions. And these both are important because of uncertain future again. So come up with a robust or flexible or robust and flexible actions which are required, right? Then you come up with evaluating those different plans you have developed, different actions you have found, different adaptation options you have found. Evaluate them with respect to robustness, with respect to cost benefit analysis, reverse to availability of technology, whatever, right? And constraints, very important. Or what are the constraints to implement those? And then you mainstream them, institutionalize them. So this is this, and this approach has been I wouldn't say extensively. We are now taking up a very huge initiative through UNESCO in applying it to about 10 countries especially in Asia. And let's see how it goes. We are still in the initial stage of discussions. So we started applying this about I would say 10 years or even less than 10 years, 7, 8 years. And we applied it to a hydropower project, which is still going on currently. We applied it to water supply systems in Bangkok, in Kenya, in Colombo, in Sri Lanka. And then we thought, let's test it, how it works in agriculture sector. So this is a PhD work of one of my former student. Now she is with the Ministry of Agriculture in New Delhi, just recently joined. So I'm going to quickly give you how we applied this concept to this, right? There will be a little bit of complexity there. So if you don't understand, then we can have discussions after this because of the time constraint. We applied it to irrigated agriculture in Bhavani irrigation project, which is in south of India. Drainage area is about 6,000. What is important here to look at the rainfall, the upper part of where there is a Bhavani Sagar Dam. The upper part of it is about 1,600 millimeter of rainfall. In the lower part, mainly the command area is about 800 millimeters, right? And command area is about 80,000 hectares. So what is the decision context and who are the key stakeholders? So we talked to irrigation department responsible for supplying water. We talked to agriculture department responsible for agriculture production, and we talked to the farmers. And we have come up with performance objective, the decision variable, the performance matrix, and threshold, right? I don't know why people want to disturb. Sorry. So try to see here, we use a performance matrix of yield, which is the interest of farmers as well as for the agriculture department. And the irrigation department is more responsible for supplying water. So we come up with a performance matrix where we try to find a ratio of supply to demand, right? And our target, the threshold is 1. We would like to, and to define the normal yield, we had a lot of discussion and come to a point where we will say that, okay, 4 tons per hectare would be a normal yield which we would like to. So we have used 2 stressors. Time is really short. We use aridity index to reflect the climate change because this takes care of both temperature and precipitation. And we use the coefficient of variation, which is reflecting the variability. So both climate variability and climate change was considered in this. We developed alternative future climate scenarios, 168, right? And then we did the stress testing. These are the response surfaces, which clearly indicates that what is the effect of aridity index and what is the effect of climate variability. Now we found that system will fail for yield at higher aridity index and low climate variability, and system will fail in supply demand ratio at low aridity index and all ranges of climate variability, right? Then we look at all possible through GCM and RCMs. We look at what could be the possibility of those future climate, which we have 168 scenarios here. And you see all these dots here reflecting that this could be the future climate, which is, we are trying to cover all possible future climatic conditions, right? So this is all possible. And for the future climate, the system will fail in almost all the cases. We develop this risk matrix. Risk matrix is based on two criteria. One is what is your performance matrix, which is yield or yield ratio, and the supply to demand ratio. And then what is the possibility of future climate? So there are 40. So we said if it is more than 30, then you have most critical conditions and your loss of yield is more than 20%, right? That way we have come up with what could be the risk. So we have risk of low to medium and high and very, very critical, where most of the future climate is going to say that yield is impacted by more than 20%, which is reflected 0.8 here, right? Okay, then we look at two types of solutions or adaptation measures. One is more looking into water management, other is more looking into agronomic aspect. So agronomic aspect, we delayed transplanting and we advanced transplanting, delayed and advanced by 1 week, 2 weeks. We wanted to see, even we did for 3 weeks and 4 weeks and all. In terms of water management, we look into aerobic rice cultivation, AWD, and deficit irrigation, right? There are a lot of results here. In the interest of time, I would like to stop, right? This is what you want, because you don't want to hear the results, right? So let me tell you that we look at the risk which is going to be and risk after the adaptation is implemented, and try to see what is the residual risk, right? And if you take a decision which may lead to a maladaptation, so you need to be very careful to see what are the performance matrices and how your adaptation measures are going to help you. I will not conclude here. You can decide by yourself. These are some of the publications which came out of this work. Please try to look at them and come back to us if you would like to get more information. Only thing is, way forward, I like all of you to think also from the research point of view that any adaptation measure should also be mitigative. So think of mitigation and adaptation.
All right.
Thank you very much.
Thank you very much.
Okay. That's good progress. Thank you.
The next presentation, will be by Professor Anish Kimeri from AIT as well. And the presentation will be on the sustainability horizon, life cycle assessment of bamboo-derived biochar production. Yeah, please.
Okay, thank you. Thank you, organizers of AAAE Symposium. Special thanks to Professor Conwer and that is Kitiopas Cup for this opportunity. So actually this is hot off the press. So the student who did this research is graduating today. So I have to, go back after this presentation, and thanks for accommodating my request. So this is, biochar has become a very popular terminology. I think among the climate mitigation people as well as agriculture in different sectors. And indeed, it has a very good impact in terms of moisture retention, nutrient retention, and among other, like it has got a very good potential for carbon sequestration, right? But those are the downstream advantages. But what it will look like if you look at the holistic picture? So what are the impacts from the upstream processes, like the biochar production processes? Okay, so this is a study that compares. So we took open burning as a baseline scenario because we have to compare the advantages of biochar production and its application in agriculture. By the way, I'm not an agriculture guy. I'm from the Department of Civil and Environment Engineering, but I do research maybe close to agriculture, but not directly related with agriculture. So we compared it with the baseline situation, which is the open burning of bamboo residues. And we look at the overall impact. But why there is need of for these research is we don't know about the overall supply chain vulnerability. So what is the impact from the transportation of biochar? What is the impact from the production of biochar, let's say the pyrolysis process, and to detect the environmental hotspot, as well as what are the impacts in terms of the carbon stability, because I think that pretty much affects the carbon sequestration potential and its benefit in terms of climate mitigation. So considering this, we applied ISO 14044, ISO 14040 framework, which is pretty much a gold standard for doing a life cycle assessment. That includes 4 different phases where we define our system boundary, we collected data regarding the biochar production and its application. We looked into the some of the background and the foreground data sets, and we did run LCA modeling, and finally came to an interpretation. So these are pretty much a standard framework for conducting a LCA. And our functional unit for comparison was 1,000 kilogram of bamboo biochar, produced biochar and its application. So we included different stages of bamboo biochar production up to its application, from the bamboo waste acquisition, feedstock transportation, pre-treatment, which pretty much involves drying process, and then the pyrolysis. So for this particular case, we use a case study from Wangpai biochar, which uses, which is called a Kontiki kind of pyrolyzer. So it's like a kind of open burn, well, not like an open burning system, but it's much more efficient than that. But it's include a Kontiki pyrolyzer, and then the biochar transportation, and finally application to a paddy field. So that was the system boundary, and we considered the using a tools Open LCA, EcoInvent, and we use a so-called recipe methodology for quantifying the impacts. So, and for quantifying the impacts from the avoidance, so we consider the fertilizer reduction in terms of the greenhouse gases. We consider both methane as well as nitrous oxide reduction. So we took data across different literature study pertaining to paddy field and its application of biochar in paddies. And so these are the inputs and output that we consider in our study. So you can see here, so the input normally includes the bamboo residue. So for 1 ton of biochar, it requires around 4,320 to 29 kilograms of residue, of course, because biochar yield determines how much biomass we need for its production. And since this is a life cycle study, so we have to consider all the inputs from the production of the pyrolyzer, transportation fuel, and everything. So as you can see from the in the avoided products, we consider the benefits in terms of reduction in nitrogen base, phosphorus base, and the potassium base fertilizer. And then the soil application credits included the carbon dioxide avoided, nitrous oxide avoided, and methane mitigated. And these are the outputs in terms of different emissions, because during the pyrolysis, during transportation, we may have direct and indirect emission. So which were all quantified within this life cycle framework assessment. And when we look at the data, well, maybe you might see there are numbers, but the numbers are pretty promising. So if you look at as compared to the open burning situation, the biochar with the soil application has a reduction in most of the impact category. And in some of the impact, you can see the negative value. So what does this negative value means is it has got a very good mitigation potential in terms of the environmental impact, specifically if you look at the global warming impact. So as you compare to the open burning, as in the Southeast Asian countries, it has a problem with air pollution pretty much from the open burning of crop residue. And during the winter time, you see that the AQI can shoot up to 300, 400, values. So I think the situation is pretty much the same in South Asian countries as well. So, the open burning, it contributes to the impacts, the air pollution and other impacts. So as compared to the open burning situation, so biochar, it pretty much, reduces impacts across the 18 environmental impact categories. You can see the human health impact measured as disability adjusted life years, ecosystem quality, resource scarcity. So among these different impact category, we have seen the impacts has been reduced. So, and then we try to normalize the result and look at the overall picture, looking at where are the hotspots, okay, whether it's in the pyrolysis process, whether it's in the transportation. As you can see from this blue bar, you can see that the transportation has a very good contribution in terms of the environmental impact. So this is a very good message that, when we are considering the production and the application of the biochar, the biomass has to be sourced from the locally available resources. And if you are, producing a biomass here and then applying it somewhere else, let's say 200 kilometer far, then the impacts is not going to be much. Okay. So, and then another important thing that we need to consider is the pyrolysis process. Okay. If we are doing the biochar production haphazardly, then the impacts we get from its application and the soil carbon sequestration actually, outweigh the impact, from the pyrolysis process. Because, if we don't control the emission from the pyrolysis process, then it is going to contribute a lot in terms of the PM 2.5. That is the, one of the indicator air pollutant or criteria air pollutant. So, and then we also look at, what is the, what affects our result. So we did some sensitivity analysis in terms of, using different emission factors. We consider different stability of the biochar. We even consider different transportation distance. And we found that the results are highly sensitive on the transportation distance and the type of the technology we use for the biochar production. So that's a message from this sensitivity analysis. And then we even, try to come up with the sensitivity in our data, which was a kind of inherent because of the life cycle inventory database that we took from the EcoInvent. So across other impact category, we found that like the sensitivity in terms of the global warming impact was pretty less. That means our results from this study is pretty robust to claim that, biochar has pretty much, good carbon sequestration potential. So the take home message is that, biochar definitely it's good, but we have to look into the overall supply chain. We have to optimize that. We have to optimize the transportation distance, as well as we have to look into the technological advancement in terms of the pyrolysis process or the biochar production process. And we also need to look into the long-term validation because, scientists claim that, biochar is stable for 100 years. But I think we haven't came across any studies, that, have a, concrete results that claims whether it can be stable beyond that. So we need more studies on that to realize its benefits. So that's the key message with this. I would like to again thank the organizers. Thank you so much.
Thank you very much.
Keep up the time.
So the final presentation of this session will be by myself. So I don't know, let me introduce myself. My name is Sakamon Devahastin from King Mongkut University of Technology, Thonburi. And I'll talk about carbon neutral meals, okay? A little bit shift from traditional agriculture to food processing, okay? Uh, where is it? Okay. So the idea of carbon neutrality is actually within the sustainable development goals of the UN, especially goal number 12, which is about responsible consumption and production. And in this goal, they said that we have to ensure sustainable consumption and production pattern, and we have to make sure that we decouple economic growth from environmental degradation. So we cannot just keep, pumping the economy, but at the same time damaging our environment. We have to decouple the two from each other, and for example, by increasing resource efficiency, promoting sustainable lifestyles. And why we talk about food sector? Because this sector contribute about 22% of total greenhouse gas emission and consume a lot of energy, maybe 30% of total energy consumption of the world. And for food product or meal, actually, we're not talking about only one food product. We're talking about meal. And in order for the meal to be carbon neutral, its carbon footprint have to be neutralized. Okay. So there is no net increase in carbon dioxide equivalents, not only carbon dioxide, but something else too, like methane, for example. And greenhouse gas emission can occur, at every single step through the supply chain, be it production, transportation, or cooking at home or in restaurants or food processing plant. And these must be balanced or offset by some measure. Okay. So we, of course, we need sustainable practices to reduce emission and offset the emission. So before we do something, we have to know first how much carbon dioxide equivalents are produced. So we have to measure first, and then we have to find a way to reduce it. And whatever part that we can reduce, we have to offset. So these are the three main steps. Okay. And in terms of measurement, of course, you know that we can do the so-called life cycle assessment to identify sources of emission. And when we do LCA, we involve raw material sourcing, manufacturing, use, and waste disposal. And the problem, of course, is that most of the time we cannot assess the whole thing. We can assess only a limited portion of food supply chain, and this need to be addressed, of course. Can see that carbon emission can take place at anywhere, can take place at farming state. We feed animal, we produce carbon dioxide. We process food at the factory. We transport food from point A to point B. We create carbon dioxide. Even at supermarket, okay, we need refrigerator, we need energy, we need all kinds of things at supermarket. We generate carbon dioxide. Even at packaging state, we produce packaging. We throw package away and everything, related to carbon emission. And if we take a look at the landscape of carbon footprint, you can see that raw material contribute half of it. And energy production at plant or even in your kitchen contribute another 30%. Of course, you transport food, you contribute to carbon emission also, but not as much as raw materials. That's the place where carbon emission take place. Now, in order to reduce it, what should we do? For example, we can implement some sustainable farming practices. We can improve feed option to reduce enteric methane. We can use cover crop. We should find a way to efficiently use water, fertilizer. We have to do manual management. This is something very important. And of course, we can adopt some renewable energy option. Now that we can reduce, okay, let's say we start from 100, we reduce it by 80. Another 20, you have to offset it. And what to do? We can, for example, invest in projects that remove or reduce equivalent amount of greenhouse gases. For example, you can grow trees. You invest in for reforestation or afforestation project, or we can invest in renewable energy initiatives using solar energy, wind energy, something like that. A lot of people, a lot of places are doing that right now. Also, we can choose some food that produce lower carbon emission by themselves, by nature. For example, if you choose to use in-season food for your cooking, for your meals, of course, you don't have to refrigerate food for a long time and use it out season. Of course, you can reduce carbon dioxide emission. You don't have to ship food from from Europe or from Australia to Thailand. You can reduce carbon emission, so you can use local food. And actually, some foods or food materials have lower carbon footprint by themselves also. For example, if you talk about livestock like beef, you want to consume beef, you know that cattle rearing contribute a lot to carbon emission. So what about something else? Like what about pork or poultry? Of course, it's better, but the best thing is, cricket or insect. If you go for insect protein, you contribute much less to carbon dioxide production. But you don't have to go for something like this. This is too much. I mean, so for some people, it's too much. Especially for ladies. So why don't we turn insect into something that looks more appealing? I mean, you don't have to serve insect like this. You can serve insect like this. Actually, this is the result from the Le Cordon Bleu. This is a very famous cooking school, and you can see that they turn cricket into something that looks nice. I don't think you would mind to eat something like this because it looks nice. Or some dessert like this, you cannot even tell that this is from cricket. So if you join hand with culinary expert, you can turn something ugly into something that looks nice, appealing to eat. You can enjoy this. And actually, if you don't have to eat insect every day. There's a study that if you are a family of 4, eating food made with insect protein only 1 day a week for 1 year, you can save 650,000 liter of fresh water a year. You can see that you can do a lot of service to the world, by changing only a little bit. And as I say, you don't have to eat every day. You can have pizza, some other day, no problem. You eat this as a backup food, for example. Now, in order to have food, you need kitchen. Okay, so you have to look at carbon neutral kitchen also. And actually, carbon emission in the kitchen take place in 3 scopes. Okay, you have scope 1, which is emission that come from sources at your kitchen. For example, you use gas to cook food. Okay, you produce carbon dioxide in the kitchen. That's called scope 1. Scope 2 mean you throw away carbon emission to other people. Let's say you buy electricity from government. So you do not produce carbon in your home, but somebody has to take care of that. Okay, that is scope 2. And scope 3 is all other indirect emission that occur along the supply chain. You call Grab, to order food. And food has to come from restaurant to you at home. You contribute to carbon emission. So next time, before you order food, think about it. Okay, should we cook at home or should we order? I mean, younger people nowadays, they order every day. They order. They stop going to even canteen because they want the comfort at home, and that contribute a lot to carbon emission. Okay. Or you want to eat tomato, you order tomato from Europe because it tastes better than Thai tomato. You contribute to carbon emission. Okay. Probably you can observe where waste and efficient energy use is occurring in your kitchen. Are you using a lot of cling film for no reason? Are you using a lot of single-use plastic for no reason? Do you throw away food all the time? Because if you do that, you contribute to carbon emission. You buy food 100%, you eat only 50, you throw away 50. And actually, you can even look for food with, carbon neutral label. In the US, in Canada, they start to put carbon neutral label. This is zero carb. Carb here is not calorie, okay? It's carbon, okay? So you can have a zero carbon beer, for example. All right. In Thailand, this is among the first food product in Asia actually that have received a carbon neutral label. This is a egg from a company called CP. This is in Thailand, and I'm sure there will be more and more product coming out in the market in the near future. Even this one, Twining tea, you can see that they have biodegradable tea bag, plant-based tea bag. So you don't have to worry about nanoplastic or microplastic next time you have tea, because if you drink tea with the plastic bag, you consume also plastic into your body, and microplastic or nanoplastic is very bad for your health, actually. You can also convert food waste into new menu. Okay, I don't have time. I'll skip this. And also you can compose food waste into fertilizer. You can buy this kind of food digester and use it at home. It's not expensive anymore. You can see that you can put all kinds of product, in this digester. And in about five hours, you get fertilizer. You can use it for your plant at home. Okay, you can put the tea bag, even cheese and so on, but you cannot put like durian rind, for example. You cannot do that. Not only at home, you can do it. You can encourage people to do it at the food factory. This company, for example, they have all kinds of sizes of composter from 1 kilo per day to 10 ton per day. Can do that. So probably what we should do is, first of all, we should promote awareness, not only on ourselves, but all to our colleague, to our friends, family, and people who are in contact with us. We promote awareness on how food are related to carbon emission. People talk about carbon emission with the car, with EV, with this, that, but people think less about food when it comes to carbon emission. So you have to promote awareness on this. How we can mitigate such impact is sometimes it's very easy, reduce the use of single-use plastic, eat more seasonal food, in local food, and we have to change our attitude and consumption behavior as a starting point. So thank you for that.
Well, I think he made us hungry. We need to have it. I think your lunch has insect.
So we have about 10-minute break. So please enjoy your coffee and tea. And we come back at 11 for the next session. Thank you very much. And I close this session. Yeah. Thank you very much.
Thank you. You had a good session.
Thank you. Thank you very much.
I think this is very
Even the third is very good.
Yes.
อาจารย์นฤมลอาจารย์ครับเขาจะโหลดไฟล์ในไทย
Sorry, yes, Joe.
เขาจะโหลดไฟล์พาไปหา
Thank you, very good.
Yes.
Are you taking care of the bed? Are you taking care of the bed? Who takes the bed? The bed. You put the time for 15 minutes? Yeah. Who's cleaning the bed? Not you. The ding, ding, ding. That lady. Oh, they're doing on the bed. Yeah, I see. The next session, actually. Okay. So, can we do the same for this one? Can you see it? Not now. No. Not now. Now. No, this should be. Yeah. What? Just really. Yeah. This is me. That is you. Yeah. And then I did what for the five? Help trade. I did that. But I said last night, I want to see, is it okay or not? Can you check? Not here. Not in, yeah. You check here. The front first. Maybe it's there.
All right. I think you have my external address. Did you pull it? Good. How did it go? Did it go good? Bad timing, so people were doing good in timing or worse? Worse than me?
In time. We send this early morning, when we send to the center, the email, we share with us, talk about it, you. And I want to check the time to see. Yes.
You know what to eat.
You must stand this.
Yes, I know. You're going to start with us. Yeah, because the rest of our line, they don't cannot get a correction. So you can get it. I follow everybody. Okay, guys, the picture of that. Come in.
What we're like talking about is
I guess I can find. You said it. That was colder.
Yes.
Yes, you know, we live again. No, I heard maybe the public. They keep the air issue so. Well, you know, any of the you see, all the same problem.
24 is a good temperature. I like that. Yeah. High school relationship, the language, the whole delivery class on this. Okay, and OP would be. They're not expected to be. And this can't. Yeah. It's not simple, this means actual massive. I did not have you guys do it. But I think this is a problem of some of these things are always, you don't get like those. I really look at the. I read it.
Yeah, I'm chair. Yeah. Yeah.
Number 1.
Yeah, we start here. We start here. We start here. We start document. Yeah, he will set for you.
If you said that you have your file, right? Where? Where? Outside. Okay, so it's just you get them.
Actually, what is the plan? They hold the million in the drop.
Oh, you gave it them, is it? I see. They haven't transferred it here. This is why just I also wanted to check my phone.
No, because the things are changing. It's not a lot of different ideas. A lot of things are people don't know. There is something to that. I just want to know. Yeah. I can't only once in a while. But he's I thought you have a copyright research. If you like to find the guys, only reason one idea from the right is but it looks like it's exactly the way you talk written there. You cannot talk to a copyright. Very good. Very good. I see that. Yeah, he's good. If you give somebody, you can. He's a very nice person. Yeah, all types of youngsters and they're all how we vibration batting most of the stuff very forward. Very how is the daily lawyer in that?
So it was old by
Xẹp đây rồi. Xẹp đây rồi hả? Xẹp đây rồi mà. So. I have some pictures to share. I'll be helping you that next year.
He is online now.
Already there. First one, first one, the whole team. And I want one session on land protection. That's what we have now. Yeah. And I have requested to leave opportunity.
Somebody is online right now. Hello, somebody is online right now.
I didn't know that. You know, you work at the even I see that. Yes. 20 years, she worked with me. She worked with Nikki and I. So,
Dr. Sangeeta Lenka, are you online? If you are here, you are sharing screen. Dr. Sangeeta, you may begin if you are ready. Dr. Sangeeta Lenka. Yes, can you hear me? But the share screening, can you share? Are you able? Can you share screen? Yes. Okay. Okay. Can you share screen with us?
yes.
But Dr. Sangeeta, can you hear us? No. Please. Dr. Narendra Lenka, I can see you. Yeah, very good. Can you tell Dr. Sangeeta to share screen and begin? We cannot hear you though.
हाँ स्क्रीन शेयर करो हाँ On-mute कर दीजिए. Yes, sir, we are able to hear. I have told Sangeeta, Dr. Sangeeta, she is going to present.
Okay, Dr. Narendra, you want to begin first? We can see you.
Yeah, I can begin, sir. I have already told her if she doesn't start, then I will start.
Okay, we can begin with you.
Okay, okay.
Okay, 15 minutes maximum, yeah? Please
Yeah,
start.
yeah. Yes, sir. Yes, sir.
No, 10, 12 maximum. 10 minutes only, Asabi always get.
So, am I audible, sir? Respected chair,
I don't expect.
No voice.
No big. They're all. This is the reason recorded should have next time also agree to send recorded messages. No use of wasting others' time. Strictly never accepts online like this, only recorded we accept. And but then I was told some of the signs so no big and all.
Dr. Narendra, can you please on your microphone? You are not muted. Please on your microphone. Dr. Narendra, can you hear me? Dr. Narendra, can you please on your microphone? It's muted. Your microphone is muted.
Unmute. Narendra, unmute yourself, please. Unmute. Mic. Click on the mic, please. If you hear me, click on the mic symbol. His number, somebody has his number.
Blocked from the host. Check from our side.
When he spoke, I heard the voice, no? It was talking. And there was Dr. here.
Yeah.
Then he told, he was talking to us. No, काम करेगा, 5 मिनट देगा. Problem ही है. He was there all the time. What is it? What is it?
Yes, sir. Yes, sir. Let me start, sir. Respected chair. Sir, shall we start? Now it is okay, sir. Yeah, now it is okay. Shall we start, sir?
It's being blocked from our side.
Yeah. So, respected chair of the sessions, all the distinguished delegates.
Okay, finally we got his attention. Please,
Yeah.
please proceed.
Yeah. So,
Thank you very much.
Yeah, respected chair of this session and respected organizing secretary and chairman of this particular symposium and all the distinguished delegates present online and offline. In fact, I thank the organizers for giving me this opportunity. This particular topic which I want to cover, it basically derives from our research work at Bhopal in India, located in subtropical and semi-arid belt of India. So this work actually we did in our research farm. Here we did a comprehensive study in combining soil scientists, agronomists, agricultural engineers, and biochemistry people to understand what is the impact of climate change, a comprehensive impact of climate change on agri-food system. So here agri-food system means I want to say that production, then soil water storage, soil mineral nutrition, then biochemical properties of seed and seed and straw. So all this we did a very comprehensive study, and this thing we did in field condition. The beauty of this particular study was this was done under field condition, not in pots. So as we all know that global climate change, when we say this covers many things, and basically here I want to cover the impact of elevation in carbon dioxide and elevated temperature. So in our study, what we did is we took two level of factors, two different factors. One was environment, another was the different levels of supplemental nitrogen. So in the environment, when I say environment, it was open field condition, then chambers, because we did in open top chambers, automated open top chambers. So this was ambient chamber condition. And then we elevated the carbon dioxide concentration to 550 to 600 parts per million by volume. And also temperature was elevated by infrared heaters by 2 degrees Celsius above ambient. And in another treatment, we combined both CO2 and temperature. We made it elevated CO2 and elevated temperature. Then this was it. There was interaction effect of to see the interaction effect of environment and nitrogen. We had 4 levels of nitrogen supplement: 50% nitrogen, 100%, and 150% nitrogen. Basic objective was to see how the plants or how the system is working when suboptimal nitrogen is supplied or superoptimal nitrogen is supplied, because nitrogen is one of the major plant nutrients. So this was done, as I have already told, under automated chamber conditions in field using SCADA softwares, where we automated when the carbon dioxide concentration was below a particular given limit, the CO2 nozzles were opening, as well as the air heaters in the temperature treatment, they were getting on. So this was completely automated. What we got from this study, what we found is the CO2 fertilization. That CO2 fertilization means the response of plants to additional CO2, additional carbon dioxide. So that we know that this carbon dioxide, when it is added extra, it benefits plants, because carbon dioxide is a raw material for plant photosynthesis. But what we observed here is 2 crops we compared for 4 years. The response of soybean and wheat, we found that they were not uniform. They were contrastingly different. And when carbon dioxide was elevated, as well as temperature was elevated, the soybean yield, soybean biomass, they were highly benefited. About more than 40% yield benefit we observed in soybean under recommended dose of fertilizer, as compared to 15% in case of wheat crop. And one surprising thing we observed here is when we elevated the temperature by about 2 degrees Celsius above the ambient, we got a very good yield in case of soybean. But in case of wheat, there was loss of yield. And these findings we have published in Field Crop Research. This particular graph, it shows the different levels of CO2 fertilization effect in wheat crop in different years. So if you can see, under elevated CO2, we got up to 24%, 12 to 24% in case of wheat, though in case of soybean, we got more than that. Here, this is the case of soybean. The lower graphs, they show that 51 to 65% increase in soybean yield over the ambient condition we observed. And this was under elevated CO2, 51%, and 65% under a combination of elevated CO2 and elevated temperature. And though in the second year there was some slight reduction, but the point is soybean gets benefited by elevation of CO2, or what we say that the effect of climate change in terms of CO2 and temperature elevation. Another finding we could see that the CO2 fertilization, that means the benefit in carbon dioxide, the benefit in production or productivity because of additional CO2, it is nitrogen dependent. And this dependence we could observe clearly in wheat. Here the left graph shows the N100, we could get to 15% under elevated CO2, whereas when 50% nitrogen was reduced, we could get maximum 4% yield advantage. So that means if we want to harvest the benefits of additional CO2, which is because of the climate change, then external nitrogen will be required. And this was very clear in case of wheat. Unlike in soybean, the lower graph it shows, it was not clear in case of soybean. That was obvious because it is a nitrogen fixing crop. Another thing we could observe under field condition, why this happens. This leaf area, this percentage change over ambient chamber, AC means ambient chamber, this leaf area, it was almost doubled in some cases, 50 to 100% in case of soybean, and also we observed in case of wheat about 30 to 40%, 30% under elevated CO2 and under elevated CO2 and temperature combination, we could observe up 33%. So that means leaf area might be a contributing factor for higher photosynthesis. Another study we did, what is the impact of use efficiency of applied fertilizer nitrogen. Surprisingly, we observed that all the 4 indices which are conventionally used for measuring the nitrogen use efficiency, they were higher under elevated CO2. Though with increase in temperature, the use efficiency it reduced. And this picture, it is for wheat crop only. This is again published in Field Crop Research. So if you see the agronomic efficiency, the first graph, under elevated CO2, it was higher as compared to the other treatments. The recovery also, it was higher. Physiological efficiency and partial factor productivity, all the 4 indices, they were higher under climate change conditions. But there was a his that we measured the nitrogen balance from the starting to the completion of the experiment. We observed that under elevated CO2, the apparent nitrogen balance, it was negative. It was lower as compared to the other treatments. So that means the plants require more nitrogen if they want to give us yield under elevated CO2 or elevated CO2 and elevated temperature conditions. This right side graph, it also shows the same. If you see the mineral nitrogen means ammonium plus nitrate nitrogen in the soil, there is a gradual decline under, this is year 3, under elevated CO2. That means plants need more nitrogen if they want to give more yield. Then if the yield is higher, if the production will be higher, then what is going to happen to the uptake? Nitrogen, phosphorus, and potash, major nutrients we studied. In case of soybean, there is higher nitrogen as well as phosphorus uptake. All these graphs show for different years. EC means elevated CO2 chambers. ECET means elevated CO2 combined with elevated temperature. So what we observed that about 50 to 77% of increase in nitrogen uptake. That means plants are drawing more nitrogen from soil. In the same way, phosphorus uptake was also higher. Potash uptake was also higher in case of this is in case of soybean. The same picture was in wheat, but the magnitude was less. Only uptake was it was higher about 8 to 13% in 1 year, and then another third year last year it was from 14 to 20%, 24%, and there is a significant increase in uptake. In phosphorus uptake, it was also higher, but under elevated CO2 conditions, the phosphorus uptake was not very high. This shows that phosphorus dynamics is little different from nitrogen. And then potash uptake was also higher in case of wheat. And we did also a root study, why it is so. You see, these are the different treatments and the wheat roots in different treatments. Under elevated CO2, the root biomass and root length, it was higher as compared to the other treatments, particularly the ambient and elevated temperature. So what is going to happen to the soil microbial diversity? Narrowing down of soil microbial diversity, we observed, we did a phospholipid fatty acid analysis, and this showed that there is a significant increase in fungi bacteria ratio and significant reduction in ratio of gram positive to gram negative bacteria. So and then ratio of saturated to unsaturated fatty acids. Also, we did 16S rDNA profiling, this showed that the microbial diversity, it is getting reduced with elevation in carbon dioxide level. This is the data of PLF analysis, phospholipid fatty acid analysis, that shows clearly that fungi and bacteria, that means fungi, they are growing more under elevated CO2 conditions as compared to the other treatments. What happened to the profile moisture storage? Because this was, if you see under different nitrogen treatments, these red bars are under for elevated CO2. The profile moisture storage was higher as compared to the ambient chamber condition. This was both in case of wheat as well as in case of soybean. And these findings we published in Agriculture Water Management in the year 2021 and 2020. Then water use efficiency, quite natural that water use efficiency will be higher. What happened to the seed quality? We observed this for soybean as well as wheat. We observed both seed as well as residue quality. But here I am showing the seed quality. Here, if you can see, among the important thing is the seed weight. There was increase in seed weight, and there was almost no change or slight increase in protein content in soybean, but clear-cut increase in trypsin inhibitors under this climate change treatments. ET means elevated temperature, EC elevated CO2. So there is clear-cut increase in trypsin inhibitors, but decrease in phytic acid. In case of wheat, we did not observe much change in protein. Protein, there was almost no change, but the gluten content, it was significantly reduced in both all these climate change treatments as compared to the ambient conditions. So what does it mean? That means the protein synthesized, it is not stored as storage protein, that is gluten. And another important point is the water absorption index, it is higher under these climate change treatments. That means the proteins which are synthesized, they are mostly of small size, due to which the water solubility is increasing in these grains. In case of soybean, the trypsin inhibitor, in fact, it is a protein that controls the activation and catalytic reactions of proteins. So thus increase in trypsin inhibitor under changed environmental condition might be regulating the breakdown of protein. And as I told, the phytic acid reduction was there. That might be because of low availability of phosphorus. Phosphorus, because the uptake was not significantly affected. So because of less availability of plant phosphorus, and here I did not show on slide the phosphorus grain, though it was not concentration of phosphorus in grain, though was not influenced, but the residual phosphorus, it was reduced. In summary, what I can say is, when we say about the carbon dioxide fertilization, that means climate change and the effect on the plant photosynthesis, net for plant productivity, there is a clearly significant advantage of CO2 fertilization in both the crops, but mostly it was reflected in soybean crop. Despite a higher gradient, we observed that the tissue nutrient concentration almost remains unaltered. This finding.
Narinder, I think it's to stop you there. The time is.
Stop. This is last slide.
Okay.
Just another 1 minute, please. So this particular finding is important because the earlier studies showed that with elevated carbon dioxide, the tissue nutrient concentration reduces. But we found here with the field condition data that it remains unaltered. And higher nutrient mining, higher water productivity, and we computed that an additional 1 degree rise in temperature would enhance wheat crop above transpiration by about 5 millimeter and decrease wheat yield by about 4% under elevated CO2 scenario. Thank you very much, sir, for giving me this opportunity. Thank you.
Yeah. Thank you very much, Dr. Narendra.
Yes,
for information for all those online, for the other speakers, try to finish within 12 minutes. At 10 minutes, you'll get a bell. So that's telling you try to finish in another 2 minutes. So we try to finish in 12 minutes so that maybe there are about 3 minutes for question and answers. If you really cannot, you want to get on, you'll get another bell. At 15 minutes, you must stop. Please. Yeah?
Okay,
so we move on. Thank you very much. So we move on now
Dr. Sangeeta.
Yeah, please unshare.
Okay, I will.
Already on set.
Secretariat. Is Dr. Rao available online, and is Dr. Surinaidu available online? Can you indicate by message? No, no response. So we move on now to Dr. Sangeeta Lenka. Over to you. If possible, 12 minutes. Yeah. Thank you very much.
Thank you, Chairman of the session, and all esteemed delegates and organizers for giving us this opportunity. In fact, at a very short notice, this online presentation was arranged. So thank you once again. Now, the topic of my presentation is mitigating GHG emissions from the Asian agriculture production systems. So when we look at the Asian production system, what is the global share of the population and natural resources? It is almost 59 to 60% of the population, 30% of the land area, and 36% of the water resources. Cattle is almost around 30 to 35%. And if you look at the food grain production, it is also 50 to 55%, and almost 90% of the world production and consumption of rice is from Asia. So what about the emissions? What is the contribution of Asia's emission to the anthropogenic GHG? And it is almost around 50 to 55%, same as that of the food grain production, not surprising. Now, if we look at the sectoral contribution in the agriculture, it is mostly the enteric fermentation, the livestock, and the rice cultivation, then the agriculture soils and the fertilizer induced nitrous oxide emission that contributes almost around 80 to 85% of the total greenhouse gas emissions in Asian agriculture. Now, when we look at the agriculture, it is not only the source, but also it acts as a sink for these greenhouse gases, especially by means of it is a potential sink for carbon sequestration. So how can we increase this sink capacity? Now, the most important mitigation strategy is sustainable management of natural resources. What do you mean by this? It is rather than focusing on fertilizer use per se, all the private sectors and policy managers should in fact focus on the sustainable management of natural resources, especially focusing on soil health management and soil organic matter content. So it is very much important to link these degraded soils and how to rejuvenate this by regenerative agriculture practices, and we can aim at carbon capture, the voluntary, and these carbon credits can be encashed in the financial market in the voluntary carbon markets, and thus attaining the sustainable development goals. So some of these nature positive or the agronomic practices, in fact, are like improved agriculture land management practices, protecting the managing and restoring the soils. That is most important, strengthening the biodiversity, improving the water quality and renewability, adapting negative emission farming. We have to reduce the input of chemicals, use biostimulants and organic amendments, promoting biocircular economy, that is most important, and supporting at the end One Health concept, and making use of the digital innovation, especially precision agriculture. So we all know that these nature positive practices are like conservation agriculture, regenerative agriculture, agroecology, agroforestry, integration of crops with trees and livestock, practices of positive soil, eco-carbon budgets. The foremost important is we always emphasize on NPK. We forget on the carbon. So the emphasis should be on carbon along with the nutrient like NPK, balanced use of plant nutrients, and then drip fertigation and digital agriculture and precision farming. So if we look at in agriculture, the carbon dioxide as a greenhouse is carbon neutral, of course, the degraded agriculture can serve as a source of CO2, and agriculture can be a potential sink for carbon dioxide with carbon sequestration, but it should be continued for a long time, or more than 20 to 30 or 40 years. So what are the practices which helps in mitigating the methane emissions? Especially, we have seen that almost 30% is from the rice, and mostly the puddle, in the Asian region, the rice is puddled and continuously flooded. So it implies more water, more labor, as well as more methane. And so what options we have for mitigating methane? It is aerobic rice, direct seeded rice, or the SI rice system, which has less water, less labor, and less methane. So here is a table synthesized for mitigation potential in rice system that includes the work from our institute by my team, as well as in the Asian region. So we can see here mostly the alternate wet and dry as has the greatest potential for reducing the methane emission. Of course, there is a nitrous oxide, and we have the rice straw or the biochar, the mid-season drainage. Direct seeded rice has a potential of 40 to 90%, and if it is flooded rice, then it is better not to allow the straw to be incorporated, because that will act as a substrate for the methane emissions. Along with the management practices, the variety and the cultivar plays an important role in methane mitigation. So the inbred versus hybrid varieties or short duration cultivars with the lower root exudations, and cultivar. So the best is going for a suitable cultivar with the best management, irrigation, and nutrient that will help us in mitigating the methane emissions. Now, when we look at mitigating options and potentials for the nitrous oxide from the Asian agriculture soil, we have to focus on enhanced efficiency fertilizers. What does that mean? We have to go for controlled release fertilizers and the use of nitrification inhibitors, which has the greatest potential, like almost around 40 to 50% of N2 emission reduction. And the other options are like biochar application, no tillage and conservation agriculture, and optimized nitrogen, the 4R nutrient stewardship. So this has got a very important role. Cover crop, residue retention, and integrated use of nutrients. That is, we have to reduce the use of synthetic fertilizer and substitute it with organic sources of nitrogen. So all this together has a potential to reduce the nitrous oxide emission almost ranging from 10 to around 50%. And apart from the reduction in greenhouse gas emissions, these management practices also has a co-benefit of improving the soil health, especially soil carbon sequestration, buffering capacity, improving the soil aggregation, soil microbial diversity. So this is in fact a win-win situation, where along with the mitigations, we also have the soil health improvement and the crop yield. We have also done work on if we can balance the soil stoichiometry, the CNP ratio. It helps us in mitigating the GHG emissions, especially the reduced use of synthetic fertilizer, bringing in more of organic nitrogen fertilizers, crop residue retention, and the most important is if we can balance the phosphorus or P-limited soil with phosphorus addition, we can definitely go for mitigating the nitrous oxide emission. So the formula is go for application of biochar along with enhanced efficiency fertilizer and precision nitrogen management can help the reduction of nitrous oxide by 50%. Now, what is the outcome? How the farmers can be benefited by from all this is we all have been hearing there is a financial mechanism, especially the carbon credits, the voluntary carbon market, and the mechanisms wherein pouring up and where the farmers can be incentivized, in fact, from by adapting these practices. And we have calculated our institute that if we can reduce the nitrogen, synthetic nitrogen by 20%, and by adapting the no-tillage crop residue management, we can earn and carbon credit of a conservative figure from 2 to 3 tons CO2 equivalent per hectare per year to a maximum of 12 to 40 tons CO2 equivalent per hectare per year. So that's not a bad amount. And apart from all this, this enhanced rock weathering has got a great potential to sequester carbon in the soil. So, and the most important principle is here the use of, we spread the silicate rocks, which is in fact a waste material from the quarry, and they will sequester the carbon in bicarbonates and carbonates or calcium carbonates that will help to sequester long-term carbon and almost around 0.5 to 2 tons carbon dioxide per hectare per year. So the conclusion is the mitigation strategy is to produce more food, definitely, but we have from a less land, we have to produce more per drop of water. We have to produce more per unit input of fertilizers and pesticides, per unit of energy, and per unit of carbon emissions. So with this, I end my presentation, and I acknowledge my this presentation to ICR, Indian Institute of Soil Science, my research team, Dr. Ramesh Kanwa, my mentor at USDA FAS Fellowship, and this President of Thai Society of Agriculture Engineering and Asian Association of Agriculture Engineering. Thank you all.
Thank you very much, Dr. Sangeeta, for finishing about 12 minutes or so. We open the floor now to any question or comment or any feedback. Yes, please. Yes, please use the mic.
See, I hear about, my name is Saeed Ismail. I'm the Secretary General of AAAE. A simple question. We know AWD, there's alternate wetting and drying, reduces up to 30% of water, plus a lot of emission of gases.
Yes.
I have read about it for 15 years, research papers. I've asked people, are there 100 farmers anywhere in India using it now for last 1 or 2 years? I could not locate even 10 farmers. Only when a scheme is running, I'm looking, finding it, the university scheme or somebody is running scheme, there some 10 farmers are there, 5 farmers. After that 6 months, 1 year is gone. I want to know the reason why AWD is so popular, why it cannot be implemented. Is there any way the scientists here can help to see at least 10 farmers every year adopting automatically without looking for subsidy from government? Okay, thank you.
Yes, over to you, Dr. Sangeeta.
Yes, there comes the policy role as well as the extension. Maybe the farmers have to be made aware of all these co-benefits, the economic benefits they are going to get. They are saving the water, they are saving, there is no yield penalty, and also the most important is if they adopt these practices, they will be also getting the carbon credits. So we have to maybe the extension has to be more aggressive in promoting these practices, because the flooding has been a very age-old practice, and we all know that the old habits are die hard. So we have to keep on going and visiting, demonstrating them the benefits of AWD. Only then I think there could be the upskilling and the large scale adoption will be definitely possible without any subsidy.
Yes, thank you very much, Dr. Sangeeta. I'm sure it will lead to further discussion on this later on. Now, the Secretary
you.
also has been trying to locate Dr. Satyaj Rao and Dr. Surinaidu, but no response. So, yeah, exactly. So we have got also no response message. Now we move on to the next presenter on the line, Dr. Joko Sujono. Are you ready? Yes, please. From University of Gajah Mada, Indonesia. Is my okay? Okay.
Okay, thank you very much for the time. I'm Joko from University of Gajah Mada University. And actually, I graduated from AIT long time ago. Okay, I will talk about the sustainable paddy rice cultivation for enhancing water productivity and reducing the emission using the AWD irrigation approach. This is the challenge posed by climate change and drought. Firstly, irrigation constraint, soil degradation, and increasing gas emission of traditional farming. We look here that during the dry season, we have a lot of problem concerning how to irrigate because the water is so limited. You can see this the irrigation canal, but during the dry season, there is no water at all. And some of the where also you can see there is no water. This is the problem during the dry season. And you can see because we usually use the chemical fertilizer during long time, and if dry season occur, the soil becomes so hard and it's difficult maybe to plant again because every time the farmers add some fertilizer in order to get the similar production. This so every time the farmers will add chemical fertilizer. Okay. You can see here increasing gas emission by traditional farming. You can see so here. All the chemical fertilizer is subsidized by government. So the farmers tend to just buy the chemical and then spread over to the farmers. And you can see because farmers usually use the flooded irrigation. When I asked the farmers, why you use the flooded irrigation? He said that I can't sleep if my paddy fields, there is no water. This is the problem commonly faced by the traditional farmers. How to mitigate the problem and to make the sustainable cultivation? We try use the alternating and drying. You can see here the soil may be cracked, but is it okay? This experiment may be 2 weeks without irrigation. They're still growing. And the other problem also, we usually found that after harvesting, the farmers burns all the residue from the paddy field. You can see here. And because we have a problem in dry season, usually we divide into 2 seasons in my country, Indonesia. Rainy season during the November to April, and dry season maybe May to October. And my colleagues from my university already developed new variety to more drought resilience that we call Kamagora that can produce almost 10 ton per hectare. This already spread out in the country and more resilient with the drought. This good for us in order to how to mitigate during the drought season. And the problem also that we have the farmers concerning the knowledge gaps. Because the farmers usually use the flooded irrigation, so it's difficult to change into the other method. This is the problem. And because also that the government policies not push to the farmers in order to follow the water saving irrigation. These are the other problems. I use this AWD that a lot of study or papers said that AWD water saving irrigation can reduce up to maybe 30% of water and reducing the emission maybe up to 45-50%, and also reduce the cost for irrigation because some part of the water maybe came from pump station that need energy to give the water. This was the benefit of the AWD water irrigation system. That this method can conserve up to 30%, and globally maybe it's different from country to country, but average maybe up to 30%, and reduction of greenhouse emission maybe up to around 40%, quite big, and increase in crop yield up to 15, again depends on the country and how to manage the paddy field. And reduction in product costs. You can see here, this is my students who try to plant the paddy in the small part, maybe 10 years ago, this one. And they also surprised that without the water, the paddy is still growing up. This is the end of the result. That's okay. And last year, I joined the project that initiated by the Faculty of Agriculture and Sumitomo in applying the water saving irrigation and to measure the emission from the paddy field using the AWD water irrigation treatment. That study conducted in East Java. Around here, we use only 2 hectares, divided into maybe 8 parts, and we measure all the emission maybe every week. But the problem in this experiment study, we use the AVD during the rainy season, so it's quite difficult because in Indonesia the total rainfall is very high. During the 1 year, maybe could reach 3,000 millimeters. And during the rainy season, in 1 month could reach 600 millimeters. So in the wet season, it's difficult to manage the water in the field. So we have to make the drainage canal. So it's not common in for farmers. So this is also difficult. Okay, this how to measure the emission using the chambers that conducted by my colleagues from agriculture this area. This the results that's quite surprising that we have 6 fields. This the non-IVD is the gray color and blue is AWD that we can see in the by using the AWD we can reduce a lot of the emission. And for the production we can get the increase the yield up to some 60% and reduction almost quite high also. Again, this is only the experiment into hectares. And this is one student in my department who tried to add the organic materials in the soil using the buffalo rumen, because in the Sulawesi island, there's the traditional ceremony that they maybe use more than 100 buffalo in order to ceremony from people who pass away, something like that. So we use the rumen of the buffalo to add the soil, and the result the result is quite surprised that by using the buffalo rumen, that the paddy's duration is reduced from 140 to 112. So reduce almost 20 days. This and the variety is the indigenous variety. So the paddies is up to 150 days. But by using the buffalo rumen as additional, they can reduce the time for planting. And the result also quite much bigger, much higher compared using the chemical fertilizer. And the future solution for innovative adaptation maybe use the smart farming. I think the all student may can develop the easily using the IoT tools in order to implement how to manage the water. And we may also improve residue management by using organic amendments, and we use the climate resilient variety, maybe drought resilient or maybe the flood resilience. And policy support for farmers may be also very important to spread out the how to use the AWD irrigation. Thank you very much for the time.
Thank you very much, Dr. Yuko. We open the floor for any comment, feedback. Yes, please.
9.8 ton per hectare. Is that from the yield that you were sharing, 9.8 ton per hectare? Is that from a small experimental?
The potential is 9.8, but the average maybe could reach 8 ton per hectares now. 8 point.
What's the average farmer yield in your area?
Maybe just 6 ton per hectare. So we can increase to 2 ton per hectares.
Any other questions? Yes, please.
Mentioned that there was 30% saving of water.
Yes.
Yeah, this is just for my information.
You mentioned that there was a 30% saving of water with the AWD method. So may I know what kind of method you use to measure the water, the actual water consumption actually? Is that based on the number of water releases you applied, or did you use any advanced method to measure the water consumption of the paddy fields?
But in my experiment, we use just small pot, so it's easily to measure. But now we also have conducting experiment using the IoT, so we can actually measure how the water can pump to the irrigation area. Thank you.
Yes, please. Same question. So let us say that. What is the ground situation? This practice is in vogue and farmers field also to some extent.
In AWD?
Yes, no, they.
Unfortunately, AWD is not familiar in the farmers. Just still small area.
This.
Sorry, one-to-one regarding the same AWD. I mean, before 3 years AWD, and with the directors, a lot of photographs and videos happened. I am a private company. I'm a businessman, and I'm also doing a lot of work. So now the question is, I'm asking simple question to the layman. Irrigation is done. For example, today irrigation done in Australia, also automated. We tell them so many hours you have to open the water, right? That's all. How many hours? Even half an hour, 30 minutes, 40 minutes doesn't make a difference. But it's only 2 hours, 3 hours to get the water. Problem. Anybody working on flood irrigation automation, I could not find in Asia anyone. So now I'm trying to find a solution. Why? 80% is done by flood irrigation. And also you're talking AWD working flood irrigation. You can measure the depth of water, 10 centimeters or 15 centimeters required for that particular crop size. But you don't have methods to turn on and turn off. Deep irrigation. And nobody cannot motorize or whatever we have. Yes, we have one more problem is we don't measure runoff. In India, I know at least runoff measurement is very less. We need a rainfall, runoff is almost glacial, not measured. Sorry, there's a few suggestions for researchers to see the result that comes to the farmers. That is a TIPLA also want to link with the industry. You tell us industry, forget the extension, tell us industry, this is the cost, we want this cost to come. Because absolutely the economics is forgotten by most of the scientists.
Very good.
Sorry, forward.
You respond?
No, it's a comment.
Just a comment.
It's a comment, sorry.
Thank you very much. Any other?
Yeah.
Last question? If not, let's thank you. Before that, so in the last segment about morning, big clap for him. Thank you very much. Very much. I would like to have a second yourself.
Before we go for lunch, I have one announcement to make. The Thai Society of Agricultural Engineering will hold our international conference this year in Taipei, Taiwan, and it will be in September. So if any one of you are interested, please join the conference in Taiwan. I'll show you the information. Okay. Yeah, this is the poster. So maybe you can make note of this. You can scan the QR code, and it will be in it will be held in conjunction with the Taiwan Smart Agri Week, and it will be during, let me see, I cannot remember now. It's September 7 to 10. Okay, 7 to 10 of September at the Nankang Exhibition Center in Taipei. Okay, you can visit the website of TSAE and get more details on that. So you are all welcome. and hope to see some of you there. Thank you very much. Yeah, you can take a picture of this and you can search it by Google. Google the name of the conference. Yeah. Thank you. Thank you very much.
Thank you very much. So now we make an announcement for our lunch. All waiting? Yes. I don't know whether they are serving insects or not. Just now he talked about the new food. So, but maybe in Thailand they do it very attractively. I don't know.
And very well, it's available.
Okay.
And India also started.
Okay.
See, India, we need also vermites. Vermite is eaten by commonly in India by northeast, south also.
Okay.
Vermite is common food.
Okay. Whoever wants a good appetizer, please join Dr. Said afterwards. Thank you very much. Sis.
Insect farmers, we should cover business. People are investing a lot of money, read about it. What I'm saying is, bro, read about it. I read the FAO regarding promoted to Africa. Africa is coming very fast. So, go and catch it up. Go for it. Please grab it. Keep on.
Yes. Can you do this? Send an email reminder 60 to me. Send to me. Then I will talk to him. मैं आपका मैसेज भी करके कर रहा हूँ यही पर यही है सर हाँ यही है वो इनको एक एक को मिल रहा होगा बहुत अच्छा चला बहुत अच्छा Thank you. Yeah, I'm going for lunch. Just I want to check my PowerPoint. I have a presentation later after that. Make sure it's okay. I can, they're looking for the file to transfer first. Okay. Timing on the file. If you don't want to delay after the tape, no file. I have this sheet. Were you in AIP? You know, tripartite? Yeah, please send my regards and your team. I will make it contact. What I do. Okay. My second comes with the AIP.
Okay, thank you. It's okay. It takes a minute. Thank you very much. Thank you very much. Have a good lunch. Okay, for lunch. For lunch. And did you get to talk to the? No, I'm asking my colleagues if they saw it. It was. We would have a nice area.
ฮัลโหลสวัสดีค่ะจะข้างนอกจะไม่ได้ยินใช่ไหมแน่ใจนะมันจะดังไหมอ่ะดังเป็นพอได้เรียกว่าป้าเด็กแม่ทำไงแม่ทำได้ไหมโอเครอดจ้าแม่ได้ยินหนูไหมแม่ได้ยินหนูไหมแม่เสียงหนูเป็นไงบ้างอ่ะทำไมโอเค จะออกจากจากคอมเตอร์แต่เพราะอะไรแค่ถามเอง Okay.
Because of what you It was only the day before it happened on 10th. Education 9th we started. So 10th hours conference was still starting. So we got the news because we airline, I got the message of airline. It's like because of the turbulence there. So it's a mad dead of the night. They are getting that message. 40 years. Afterwards, it's difficult. That's it or not? I know it just say you want to get to the garden set up that. I'm just hoping that solve this deal.
Thank you. On that, next to this. I'm going to go.
Vacation, you never take me. With traveling, going there, I universities.
You see, you have your boss. I was thinking of I went for it. I never just said boss, but the fifth boss is also. And I my boss. No, see, all, I know. That's why all this is, we put all this is. Okay. Otherwise, you don't have to. Oh, I think that's the way. That is what's not.
No, they have.
I don't want to do it, right?
He's the boss.
He's my.
Are you a boss?
You're the boss.
They're all looking for talking about boss.
I would never force it, I would be forced to walk on the. The guys he does have big force.
Yeah.
Otherwise, he won't be. It's like only one force.
Yeah, I have.
So what is it?
But I was just a kilo, but I was going to be
There, it's not with this, but it's not just what you supposed to do, right? Yeah, so
That's the first one, and immediately go, yeah, do it.
yeah, but yeah, I.
But then,
And now most of them. That's not the better. You know, I said that. It's just clear because the value like I'm speaking now, so I'll just be very gentle. That's what I know when that name. You say it, but she going from the bush. I didn't really like going to look. I should start. Say that I say this with the permission of my wife. If you are to think that I know I control learning the head. How is it? That's it. Well, shape of it. But isn't
everywhere universal people, even different skill power. Only they sacrifice, second is they can follow their best. So power, mental power to control this, and I will. I was plus your I know. I see that. Ask every but then I take responsibility. It's my complaint. That's I'm not told that I will not tell them. This is my philosophy. I was
Hello, good afternoon, everyone. Let's start session 3. Sir, photo. सबका photos है proof. Shall I start, sir?
Yes. The boss.
Yes. 10 minutes. We are on time. Thank you. Once again, good afternoon, everyone. Without any further delay, let's start our session 3. In this session, there will be 7 presentations. Each presenter will get 12-minute time, followed by 3-minute question answers, if there. So in first 10 minutes, there will be bell, and in total 12-minute, presenter has to finish his or her presentation. This is the simple rule we are following since morning. So in this session, I would like to invite as a first presenter, Dr. T.B.S. Rajput, President, Soil Conservation Society of India. Rajput sir, now your turn.
Thank you. Thank you, Dr. Jeet, esteemed Professor Kamar, Ismail Saab, Indramani ji, Darius, and all other friends. I'm very happy to be here in Bangkok. It's a good place, and I thank you all to let me be here. I'm going to talk not my research alone, but I have tried to compile what India has done and what India is doing in terms of research, in terms of policy changes, and in terms of development. So you can see that India, water resources are very limited. You can just per capita availability. I remember Jeet was telling 7,000 cubic meter. We have very close to 1,000 cubic meter. So that's the difference. And with that difference, the changes of climate that you are seeing, and these are different challenges. I'm not going to get into it because already people have talked on that. Now, normally we think that the old things are bad and we are more smarter than the old people, the earlier people. That is not the case. So I have tried to see that what old traditional models we have. Now see, we have some of the samples, some of the examples here. These moves really fast. That you are seeing is the reverse or the inverse temple. And it is something, a good technique to save water for real dry seasons. Dr. Babel is sitting here. He belongs to Rajasthan. And in that area, water is a real precious commodity. And that is the way that they used to save it. And all other places that you are seeing, all the techniques, they are all traditional techniques I have just tried to put together. And what we have done, we are trying to mingle technological innovations with infrastructure innovations and institutional and policy innovations. Now, everywhere, the contributions are very significant, particularly infrastructure, see, watershed management programs, farm ponds and percolation tanks, and huge success has been achieved. I will show you some of the results. Then policy. The government has been really after it to save the water and increase water use efficiency. PMKSY, Pradhan Mantri Krishi Sinchai Yojana. That is the plan to bring all sort of different activities related to water use at one place, particularly in agriculture. Otherwise, there was some canal irrigated, some tubal irrigated, some personal irrigation, some pond irrigation. Everything has been put together. And water use associations are being created, and state level subsidies and in other interventions are being done. Now see, this is just one of the sample of watershed development what the country is undertaking. In such a small area, you can see how many water storage structures have been created. And these are all artificially created. There were no natural water storage water body was there. And they are under the watershed development. If you talk some success stories, Rajasthan revival of old water ponds, particularly in all villages called jords, they are being renovated and reclaimed. And Maharashtra, Jalyukt Shivar Abhiyan, then Punjab's crop diversion effort, and Andhra Pradesh AMI project is the one of the largest effort put together in a contiguous area of micro irrigation that was in erstwhile Andhra Pradesh, and it has really borne fruits. I'll be talking if the time remains. Then, very important, very sleepy, means it's not publicized much. Lot many rivers have been rejuvenated in the country. And you see one example I'm quoting, 700 Kerala villages waded through a dead river, desert, and brought it back to life in 70 days. And the main effort was from women, starting from removing weeds, dredging, reshaping, and the river is of this shape. After 70 days, the minister is traveling in that, which used to be a Nala. And this is not the one case. You can just see how many rivers have been rejuvenated already. Coming to micro irrigation, the technological intervention, just that first graph, if you see, the government has been putting so much effort. Every 2 years, a new mission is launched to propagate micro irrigation. And the companies, to stop them and to check their activities, Bureau of Indian Standards simultaneously started a committee on that. And this committee developed so many standards so that exchangeability of parts and commonality of the system remains. And BIS marking becomes a standard for any scheme of the government. You are seeing the Indian map. There are 25 centers working as Precision Farming Development Center. They are created by Government of India. And along with this, if you see the list on the first left-hand corner, these are other efforts of ICAR, Indian Council of Agricultural Research. Different schemes related to water have been initiated. So with all these concerted efforts, what we have achieved? Now, PMKSY, Pradhan Mantri Krishi Sinchai Yojana, the major effort is to use effectively the canal irrigation water. The efficiency of the canal irrigation water is close to 30%, not more than that. So the Prime Minister took a very wise decision that at least 20% of the canal commands must be brought under micro irrigation. The tail end reaches where the water is not reaching, create ponds, create water storages, put the canal water there, use drip irrigation. And that is really helping, and it has horizontally, the spread of irrigation area has been increased. All these different techniques, the technologies. The latest example I will talk, the last where you are seeing the small cars and the solar panels. This is an example in Punjab. Is a canal bank. All solar panels have been laid along the canal bank. The energy created by this is used to pump this water and use the low hills, which is called Kandi area, which was unirrigated. It was never irrigated. That area has been brought under cultivation. Similarly, this is the example from Gujarat, one other state, where the solar panels are put on the canal itself. It gives other benefits also, not time to discuss all that, but it will save water, it will save land, and it will be giving the energy without taking any land. Similarly, that green, this one that you are seeing is a map, Google map from Haryana, where the canal water is stored in a structure that you are seeing, the square. It is a reservoir created by the farmer himself. He is taking all the canal water into the reservoir. And then the reservoir water is being irrigated, the whole field is irrigated by drip irrigation. So these are the different activities going. And if come to micro irrigation has not only solved that problem, but brought those areas which were never irrigated. Deserts, the vertical farming, all sorts of vertical farming. It was never thought of. It is just not possible without micro irrigation. Now, all that, if you see the effort of all that, you can see here, world micro irrigated area, India is number 1. So all the effort of innovations, policies, standards has brought India at number 1 position in the area coverage under micro irrigation. These are some of the other success stories. There's hardly anything, but Ramthal is worth quoting. You Google Ramthal, it is the world's largest single head drip irrigation system, 24,000 hectares. And I am proud to have remained as a consultant for this particular project. Now you see, you are talking of AI, there's a lot of market and a lot of startups. More than 10 startups are already developed in India for using water more efficiently. With that, I think I'll just thank you. And the message is very simple. You use old technology, old traditional knowledge with modern technology, and with government policies, we can succeed. Thank you.
Thank you, President sir. If you have any question, so 2 to 3 minutes. Yes, 2 to 3 minutes question. If there is any question, question.
Your microphone, one more.
No, you can come there.
My question is really fantastic, but is when they do irrigation and applying it to the field, is there any salinization, soil salinity problems that has been coming, and how are those two actors, the old techniques versus the government policy, helping to address the salinity?
Salinity is the regular problem. In entire canal-based irrigation, we have the problem, particularly one of the largest canal, Indira Gandhi Canal, going to Rajasthan. It is going into very arid area, and somehow the soil there, the subsurface was calcareous. It could not see further, and the total salinization has taken place. So now one of the solutions that we are saying that you use micro irrigation, at least you will use less, you will put less salt onto the soil. The reclamation otherwise is the only solution.
You also have a sodic soil problem in Maharashtra.
Yes, yes.
Yeah, I just wanted to, little compliment that the base in Maharashtra and our university is doing, the 3 things. Reservoir is creating compound, using solar pumping system, and going for micro irrigation. So 3 times the area we could increase the irrigated area, and 3 times we could increase the productivity, particularly in pitch and pick crop. So that is Thrissur technology we call it. Thrissur technology. 3 pump. So I think this is a solution, not to be technology. Compound technology, and we are using this one, tail water, what you are saying as a compound in university also. So those things need to be popularized.
They have been done at a large scale, and that's why you could cover the largest area of micro irrigation in the world. Otherwise, India would never.
Professor Kanwar was mentioning that India is supporting it wholeheartedly, even by giving incentives and subsidy part.
60% subsidy in India. Very
Yeah,
good.
again, and that's how.
And
This message is up to 80.
And regarding Bihari's question was salinity. India is blessed due to monsoons.
Yes.
Monsoons temporarily they flush out salt.
Some of them. Still, we have 22%.
Any other question from any other person? Thank you. Thank you.
22% land is. Thank you, Prashim sir. One second. One second. Just go ahead. Thank you.
Yeah, 1 minute.
Thank you. Thank you.
Thank you, President sir. Now I would like to invite Dr. Abdul Rashid bin Mohammad Sharif, Professor, President, Institution of Geospatial and Remote Sensing, Malaysia.
Thank you very much.
Welcome.
Okay, you can hear me, yeah?
Yes.
It's better to use the mic, huh? Okay, today I talk about the GeoAI, GeoAI for modern agriculture. Now, when I say geo, basically it brings in the location, the coordinates. You can, okay, online. Okay, the coordinates come in. This is the important difference is that. Now, you know the power of coordinates, the location. It is driving the modern agriculture and also all aspects of our life, including security. Now, this presentation done together with my, this is a PhD student who graduated under my supervision recently. So, acknowledgement also to GS Dr. Veena Shashikan. Here. Okay. We are talking about next on the climate change and the future of agriculture. And we look at the rain-fed agriculture, the water insecurity, livestock system, and smallholder barriers. Many of these topics are also touched on by earlier speakers. Yeah. So I will not go into detail of that. Later on, towards the end, I'll bring this all together for you. Oh, okay. Go to the next one. Next one. Okay. At the foundation of modern agriculture, we are looking at the precision, field level management powered by satellite, drone, and AI-driven variability. By the way, precision only come in later in the 1990s when there is a GIS or GNSS. Before that, please do not assume that farmers were not clever, that they don't know about location or about the spatial variability. Farmers over the centuries knew very well about the location, but they did not have fine maps to record previous events or records of previous history. Now, this creation of the GNSS, including GPS, helped such refined calculations. And also we have that, sorry, go back. We have also issue of resilience, sustainability, and inclusion. Again, these are the three topics I think earlier speakers also have gone into detail, and I believe all of you are very well versed in that. Oh, fine. Okay. Now, Earth observation technologies for climate change agriculture. This embrace the Earth observation in agriculture plantation for precise data-driven decision-making, integrating satellite imagery, drone mapping, and IoT sensors, and farmers can optimize input, detect crop stress earlier, and improve overall productivity and sustainability. That is the leverage of modern-day available technology. And this will include the smart sensors and IoT, which can monitor soil, water, crop health, harvesting and mechanization, which include the GPS-guided robots with automated harvesting and real-time data transfer, big data and AI, analyze the Earth observation and sensor data for precision agriculture, integrated cloud platform, centralized Earth observation, weather sensor, and drone data to improve farm management, drones and aerial imaging, which have high resolution data spatial data for plantation and crop management. So these are available technologies. It is actually at our discretion, at our control, whether we want to maximize and use this or to neglect using it. Now, some of the application of this goes into precision agriculture with targeted input, to crop health monitoring, to climate resilient agriculture, soil and water management, yield prediction decision support, and these are all geo AI applications for agriculture. I don't know if I left out anything, but really, this technology encompasses the whole of the spectrum of agriculture. Now, for a long time, technology was taught separately from agriculture in university faculties. It's only the last decade or so we see there's some convergence. Even then, its technology is given a secondary role. But you will see later on how this is about to change. Now, precision agriculture has been here for some time, and we have key benefits here. For example, you can reduce the production cost through targeted input use, improve crop yield and quality, efficient fertilizer and irrigation, and significant reduction in chemical overuse and environmental runoff. So one of the issues here always is that, do farmers have the technology? Do farmers have receivers? Do farmers have GNSS, GPS? Now, I want to put it here to you. Precision agriculture does not require the satellite. It requires location. I once had a student in Germany. I spent a semester teaching there. He was from Spain. The parents cultivated oranges, and he wanted to use precision agriculture. So what they did is that they go by the rows where they cultivated the oranges, and each row was labeled. And at the end of each row, they collected all the oranges into a crate and counted the number of oranges in each crate. So monitoring the productivity, no GNSS was used. So it's up to the ingenuity of the user how to go about this. Now, here I give some example from Malaysia, where we actually use this Geo AI for machine learning. We use machine learning, which is an AI approach, and we use thermal sensor and synthetic aperture radar. This is the radar data from the satellite. It can go through the clouds, yeah? And we're going to classify oil palm trees for the basal stem rot disease. These are the images taken by the thermal camera of the trunk of the tree. Okay. Now, basal stem rot, you see the yellowing of the wilting of the older trees, the front collapse, and there's a poor growth, and there's few or no bunches and soft brown rot and decay at the stem base. And the fruiting bodies, they're mushroom-like structures. You see the mushroom-like structures come over here. And by this time, it's very late to save the tree. The tree will die. And also the severe cases are here, what we say, the palm death of falling. This is a severe problem, the most severe problem of oil palm in Malaysia and Indonesia. And I don't know about Thailand, probably start to have it as well. So if we can solve this problem, I think you can get the Nobel Prize for agriculture. Now, so use of if we try using the synthetic aperture radar, which is polarization, horizontal and vertical, and the temperature sensor, and we were able to get more than 90% accuracy in identifying the infected trees. This is just an identification, because oil palm trees are over thousands of hectares. So getting the knowledge of which tree is infected is important. So identifying the tree doesn't mean we solve the problem. No, it's just the start of the problem. Now you can try different treatment on the tree. Okay, so also we can do crop health monitoring, and we have also done another research or project where the industry approached us. One plantation company came to us and said, we plant the oil palm trees, but within the 3 years, some of the trees go missing. Okay, and the oil palm trees normally live productive 25 to 30 years. If we can replace them in the first 3 years, we can have a productive area. If we do not replace them after 3 years, they do not replace because they manage oil palm as a plot base. So our job was to try to find the missing trees. So we went to the space. Okay, why they are missing? They can be attacked by animals, they can be attacked by disease or infestation, or there are some operational consequences. Now here's a picture of the red dots represent the oil palm trees. Do you see the green area here? Can you see that from behind? Yeah. So this area here, this is where the trees went missing. So our job was to try to identify this. So we can identify this ideally with the UAV now because we got the high resolution. But identifying and counting is a different process. You give your staff a lot of pictures. They got a headache. How to identify all the points? But we put it into our computer systems, so we can identify it, get the coordinates, and give a plot where for the worker to go and plant a new tree. Okay. So next we go to soil and water management. We look into smart irrigation, soil fertility mapping, and water conservation planning. Again, all of this you are experts, but we try to help you, assist you further with the GeoAI. And here is an example of, I was talking to Professor Ramesh just now about the drought in Malaysia. This is the example of drought in North Peninsular Malaysia in Chuping. It doesn't happen every year. It doesn't happen all the time. That is this, but it does occur. So we have sometimes severe cases of drought in South Thailand to North Peninsular Malaysia. So now, there are challenges of GeoAI applications. Yeah, it's a high technology and infrastructure cost. So it's not cheap to do it. Okay, US has done it to some extent. Japan done a lot. Europe done a lot. But in the Asian developing countries, we struggle with this, trying to convince governments about investing in this. There are also issues of data privacy, ownership, and governance. And nowadays, with the world of scammers, we have to be extra cautious as well, because a lot of people get information and they misuse it as well. So that is going to be an increasingly important problem. And here, the limited digital literacy and rural connectivity. How do you get farmers to use this? We once had a project with farmers doing paddy areas. They're small plots, 1.2 hectares or so. We were laughed at. This was, I think, 2005. How can you ask farmers to use satellites? Crazy, eh? I'm talking about 20 years ago. So surprisingly, the farmers are much more knowledgeable than many people assume. So we give the imagery also to the farmers free of charge. And believe me, the farmers were so proud, because they managed to solve some problem in their own field with that imagery, no computers. And when the local member of parliament went there, they put the picture of the satellite image on their wall. They show, look, last year, this is the area where we had the paradise island for the rats. Because when you don't level the field flat, there's some area that comes up, rats go make their home there. And from that home, they attack the paddy. And then the following season, the farmer just level it off. Okay? And then following season, he see an increase in his yield. That's why he see. As simple as that, sometimes. Okay. And we also look at the inequitable access in developing nations. Okay? But we also continue to ask United Nations, when they allowed satellites to function over the world, there was an agreement. There's the principle of United Nations observation. All countries should have access to the data over which they are observed. Let's say the satellite flies over Malaysia. Malaysia has the right to ask for the data. You observe our country, why don't you share our data? So I think as agriculture associations, we have to reinforce this thinking. Now, this is coming to one of the take-home messages. This is, if you can remember this message, to me, I'm successful today. Just this one message. Why? I'm asking you, we are going towards a GPT, not ChatGPT. Just like ChatGPT, same. You're talking about AI, okay? But AI needs training. How does AI become clever? See? Because we need data. We need intelligence it can deliver from the drought, for crop health, yield prediction, irrigation intelligence, disaster, food security. So AI-powered digital twins, somebody spoke of it earlier the day also. So all of this can be created to solve all of these problems using this data from satellites, from the SAR data, from climate and weather sensor, soil topography, field and IoT sensors, map and socioeconomic. And this will changes from reactive farming to predictive agriculture. We can anticipate ahead of time what is going to happen. And this will give us better insight, better resources, better resilience. In fact, I tell you here, to get all of this data, who has it? Who has this data? You guys have it. Why I say that? Sir, you collect a lot of data in your projects. All of you collect a lot of data. After your project is done, your research analysis is done, your paper published, what happened to the data? Think about it. If you don't share this data within an Earth GPT, we can never build the intelligence. If we share, if today in this forum we make a decision, let's share the data ahead. In future, 5 years, 10 years, we will have a very intelligent system. And sometimes those localities come back to location. Thailand, Malaysia, similar location. Even the US, some areas have similar weather like Malaysia and Thailand. So this will build up the intelligent database much required by the generations to come. And you will be the major contributor to this. Okay, so finally, the road ahead, as I said to you, is to open access geospatial data, the partnership we should develop, the capacity building, and the governance and data frameworks which will come and benefit people like you. With that, I say thank you very much.
Thank you, Professor Dr. Abdul Rashid. If you have any question, just one question. If you have one question or suggestion.
What you told about digital twins, it's getting very popular. Digital twins is getting, for example, like the Reserve Bank of India or public in India. Agriculture people are working in digital twins. We have to work on digital. And those who don't know, I just explain two lines about what is happening in the field. You simulate here with a computer screen. You get the data, input data, sensor. That simulation, you see a different variables of inputs. So this, I think, if you're not worked on it, I would recommend you all to learn about digital twins and start working. Thank you.
Thank you, Dr. Sayed.
Just to supplement that, Maharashtra in India, so we are collecting all the data electronically, but not only from researchers, from all universities, all cases data, all research paper data, all government data at one place. That is not as if AG elected all data. That will have, that is the message which you are saying that we are doing, and this is a very important message we should do it.
Can you public get it?
Exactly,
sir. Thank you. Thank you very much.
You're waiting for cameraman. Thank you.
Thank you.
Thank you.
Thank you, sir. Now, our third presenter, Dr. Sandhya Rizal, researcher, Cheongyang University of Technology, Taiwan.
Thank you, Ji sir. Good afternoon, everyone. Actually, I am not exactly from the agriculture background, but Professor Sakamon has opened a platform for me to talk about the food waste so that I can link in the agricultural system. He talked about the food, and now I'm going to talk about the management of food waste. To begin with, let's look at the global food waste scenario. If we see the recent year, especially in the consumer level, we can see an increasing trend yearly. This shows not only about the wasted food materials, but it has global impacts in the environmental and economic system. So if we look at why food waste system matters a lot, is it has impact in the climate, emitting 8 to 10% of global greenhouse gases. Likewise, different resources like land, water, energy, and labor embedded during the production of food, as well as the organic nutrients that are embedded in the food waste, and they are lost due to the mismanagement of food waste system, like the open disposal or the burning system, which degrades the soil health and productivity. So if we look at the management options these days, there are several managing options that are adopted by the municipal government, like the simple disposal, including landfilling or burning of waste through incineration, and many recycling processes such as composting, anaerobic digestion, and others. However, these management options has different environmental as well as the economic burden, like the emission of greenhouse gases, leachate pollution into the environment, and operational burdens like the transportation costs or the equipment management burdens. So our municipal government has adopted composting as a better recycling approach among all. And today I am going to give my talks on the recycling through composting, as it has different beneficiaries, like it reduces greenhouse gas emissions and conserves resources embedded during the food waste food production and its management, and it improves the soil health and other economic benefits. So, is recycling always a sustainable management approach? So, if we look at the recycling management process, there is existing challenges behind it. Like when we see the collection process, if the compost plant is near to the community, then the transportation cost will be lower and the emissions will be lower, as it shows different environmental benefits. But when the compost plant is far from the local community, then the transportation cost rises, as well as there is the need of high labor and several emissions issues. So, but if the compost plant is near to the plant, what about the amount of food waste collected? The amount of food waste collection will be lower. But in contrast, if the compost plant is far from the community, then the amount of food waste collected will be more. So what about the economy of scale? There is direct as well as inverse relationship between the recycling and the collection location. So we can say that recycling everything everywhere is not always a sustainable approach. This focus us to introduce the optimal recycling boundary concept, whose goal is to minimize the recycling cost by balancing the transportation as well as the treatment and spatial efficiency. And we consider 4 main factors which determine the recycling cost, including transportation, treatment cost, recycling amount of recycling waste, treatment rate, and the spatial density. This facilitated us in designing the appropriate recycling boundary for sustainable food waste recycling. And we use this simplified equation to determine the optimal recycling boundary, where we can see that the average recycling cost is directly proportional to the transportation cost, and it has inverse relationship with the treatment or the spatial efficiency. So we applied the simplified recycling equations in case of the different municipal governments in Taichung City in Taiwan. There are 29 districts in the city, and there are 6 different recycling plants in different districts. And the average annual food waste generation of the city is 217,000 tons. But it has very low food waste recycling system, that is less than 5%. And among different 6 compost plants in different cities, we selected District 14 as the appropriate one, as it is the largest. It has largest recycling capacity, and it showed the lowest unit treatment cost. Now, this graph, if we look at the graph, it shows about the relationship between the unit total recycling cost for radius of the recycling boundary. Different costs, we have used different recycling rates. The different colored curves, they shows the different recycling rates starting from 5% to the 100%, and the blue dotted line, it shows 3 different scenarios. That is N1 over the left side, and N2 is the strategic. That means the optimal recycling condition that we found from our equations, and N3 is the lower recycling rate, that is right side of this recycling boundary. And the orange dotted line, we can see here, the orange dotted line is the lowest minimum average recycling cost for each recycling rate. And the yellow dotted line, this shows the 10% rise from the lowest minimal cost, because we don't want to limit the municipal government with the lowest minimal cost, giving flexibility for 10% rise in the recycling cost. And the key findings from our study was that we found the trade-off relationship between the transportation, treatment, and spatial efficiency. For the recycling scenario, the transportation cost was directly proportional to the total cost, while the treatment cost was it showed the inverse relationship with the recycling rates. And the spatial efficiency was a determinant factor to determine the lowest minimal recycling cost. Likewise, the facility in different locations, the distance of the facility in different locations towards the community, it helped determine the lowest possible recycling cost in the area. So the data-driven spatial optimization enables cost-effective, low-carbon, and climate-resilient recycling systems. Besides economics, there are several environmental implications based on our study, like it has the direct relationship with the climate and the agricultural system. Is the after recycling the nutrients from the food waste, if it is able to return to the soil system, then it helps to improve the soil productivity and fertility. Likewise, the dependence in chemical fertilizers will be lowered, and it overall improves the sustainability of food waste management in the system. So optimized food waste management supports resilient agriculture and the circularity of the environmental system, as well as the sustainability of the community. With this, I want to conclude my talks here. Thank you.
Thank you, Dr. Sandari ma'am, with your very informative presentation. And without any further delay, I would like to hand over the certificate of your presentation.
Only my questions. Only. Thank you. Thank you.
Now, our fourth presenter, Dr. Brijesh Kumar Yadav, Professor, Department of Hydrology, Indian Institute of Technology, Roorkee.
Dignitaries sitting on the dais of the dais. It's my pleasure to speak for this August gathering on sustainable groundwater resources. As we are aware that agriculture, especially in the South Asia, is very much dependent, especially on the extreme event side, on groundwater resources. So without the development of the groundwater resources, we cannot expect and also under changing climatic conditions, we are more reliable on the groundwater resources. So if you look at the issues related to the groundwater, especially in the South Asia and in Indian subcontinent, we face mostly the groundwater depletion, overdraft, or the land subsidence because of the extraction, and also this waterlogging issues at very localized issues, and saltwater intrusion. And I think the first talk when Dr. TVS was talking about, someone was asking about the saltwater issues. So seawater intrusion in the coastal region, especially also in the terrestrial region in many parts of the Asia, is a very big challenge for the agriculture. And last one, but not the least, that is the groundwater contamination by anthropogenic and geogenic pollutions. So if we talk about these are the kind of the contaminations, so I'll talk mostly about the salts and the kind of you can say the other pollutants. So first about the salinity, if you look at the salinity, this is the map which shows the terrestrial as well as the coastal distribution of the high saline groundwater. And why I'm talking about this high saline groundwater, because if you look at in the South Asia, you can see all these coastal cities where the intense agriculture in the peri-urban area is taking place is also badly impacted by the agriculture and the salt impact areas. So, and Indian conditions, you can see not only the coastal region, but also the terrestrial region, especially in the north and western part of our country, where my hometown is also there in the Rajasthan. So these are the part where we have the severe salt issues. And to challenge with that one, we go for the groundwater, you can say the development. And these are the many techniques we talk about, that we harvest the rainwater and then divert into the subsurface. And at the time of the need, we take out this fresh water.
So these are the conventional way, but if you go for such type of the techniques, especially in the salt impacted area, their impact is not going to be, much useful, fruitful, because the salt which is going to be there into the subsurface is going to have like less recovery efficiency. When I talk about the recovery efficiency, because whenever the amount of the water which we divert into the subsurface, that need to be also brought at the surface. So the recovery efficiency in the salt impacted area is very, very poor. The reason is that when we divert the fresh water in the subsurface, a fresh water pocket or the bulb is made over the groundwater table, and whenever we recover this groundwater, then we don't get the fresh water, rather than we get the saline water, because of the mixing as well as the diffusion that is made between the fresh and the saline groundwater which is there in the aquifer. So question come that how to increase this recovery efficiency, especially in salt impacted areas. So this talk is more, you can say, technical. So here we talk about the managed aquifer recharge. So where aquifer storage and recovery we talk, where in the first phase of the aquifer injection, we collect the surface water. It can be from any source of the fresh water. We divert into the confined or unconfined aquifer, and then it keeps storage for some time before we take it out at the surface. So this is going to be the entire cycle of the fresh water which we inject into the subsurface. These are the major three phases, like injection phase, storage phase. Injection phase comes into account whenever, especially the monsoon period or the rainfall period of the country. And then storage phase is there between, you can say, the post-monsoon phase. And then the recovery phase, especially the pre-monsoon phase, where we are more relying on the groundwater sources. So when you go for the recovery phase, you can see the fresh water, which is going to have the less density as compared to the saline water. It comes at the top because of the buoyancy force or less density. And when we try to recover it from the single phase, single well, the saline water comes out at the surface. Therefore, the recovery efficiency is going to be insignificant. So for that one, we have to take into account all the factors. So this is the picture which shows more detailed picture. You can see here, there is especially the rainfall pattern of the site, and then all these three phases. So for better recovery efficiency, what we need to do, we need to plan these things. These are very, very important. Like we have to go for the site-specific aquifer characteristics, as well as the designing of the ASR well. It is not necessary that we go for the one single well, but multiple wells at the, you can say, different depths are going to be useful when it comes for the better recovery. And then the operational factors of the ASR, what should be the injection rate, what should be the total volume of which we are going to divert at a site, and also its recovery rate. So these plays very, very crucial role when it comes for the improving the recovery efficiency. The role of the fluid properties, especially the contrasting density, the fresh water as well as the saline density, which we are talking about. So if we bifurcate all these factors, so these are the four different types of the factors, like especially the planning factor. So we need to identify what are the different sources of the fresh water which are available, whether it is coming from the river water, rainwater harvesting, or desalinized water from the saline water. So these can be the different sources. And then the potential uses, mostly we're talking about here the agriculture. So that can be the one of the, you can say, the potential use in the agriculture sector. And then the investigation, especially for the site, like aquifer geometry and hydrogeological investigation we do. So what are the kind of the aquifer, what are depth, transmissivity and all, because these parameters of the aquifer are very significantly playing a role, especially for improving the recovery efficiency of the site. And then design of the ASR, like whether it is going to be well clogging, whether it's going to be, you can see, the plugging of the wells and all. And then the operational factors like injection rate, operation volume, and the storage duration. Okay, and then how many ASR cycles. So 1 year, Julian year, we go for the one cycle. So these factors we have taken individually, we have identified them. And then what we found that, okay, these are the very, very important things, and these are very localized, especially for the site condition needs to be taken into account for the improved recovery efficiency. Similarly, in the coastal region, the base flow, what we call SGD, submarine groundwater discharge, that is also very, you can say, the freshwater sources which we load during the post-monsoon season. So identification of such type of the pathways, so this submarine groundwater discharge is very important, not only for the better availability of the fresh water in the coastal region, but also for checking the seawater intrusion, because there may be some zones where the seawater is coming towards the terrestrial water, aquifer water, and the rest of the zone where the base flow is silently going to the seawater. So by identifying such type of the hot spots, we can also improve the water availability into the coastal zones. So we have done this for the entire Arabian, you can say the coast, by using the 3 stages. First for the remotely sensed data, where we have seen the seawater temperature anomalies, followed by the hydrogeological investigation, by geophysical investigations and all, and finally by hydrogeochemical investigation like isotopes and all, to see that how the water waste flow which is going to go into the sea is connected with the coastal aquifers. So these 3 parameters, and apart from that, we are also handling this NIUA through NIUA, Mahua, Ministry of Urban Affairs and Housing is also one of the agency where we are taking care of the groundwater rejuvenation in Maharashtra and MP, and our 2 states. So each city we are having the 10 sites where groundwater recharge sites are being to build, and that is going to have very encouraging results. We are going to expand it for the pan India. And for the water quality point of view, groundwater quality point of view, we understand that the geogenic contamination like arsenic and the fluoride is one of the, you can say, the widespread pollutant in the groundwater. So conventionally what we do, so people at the household level, they take out the groundwater which is highly, contaminated by arsenic and all. They pass it through some treatment system like this, you can say, column setup filled by different types of the adsorbent. People get the fresh water, and whatever the reject is there, they are actually releasing at the surface. So that is also going to pollute the surface resources. And ultimately it is going to pollute not only the soil water sources which are free from the arsenic, but also the vegetation and all that is indirectly taking up the arsenic, and that is going to enter into the food chain. So for that one, we have to identify the in-situ treatment, and for that one, we investigated this permeable reactive barrier, what we call PRB. So permeable reactive barrier is the, you can say, type of the adsorbent which is fitted with the well screen. So because whenever we have the tube well, so such type of the setup can be built at the entrance of the groundwater where it is going to enter into the well. So such type of the setup can remove the contaminant at the site or at the place where these pollutants are happening into the subsurface. So what we call in-situ treatment. So such type of the technology needs to be developed at the pilot scale. We are doing it in the Bihar as well as in some part of the UP. So we are integrating the wells with this such type of the permeable reactive barrier with the help of the DST and other sponsoring agencies. And then finally, indeed, we need to ask that whatever the contaminated site, whether it is salt or any geogenic or any emerging contaminant or any other conventional pollutant, whether it is going to be remediated or not, what kind of the remediation techniques are feasible based on the, you can say, the challenges or the site locations. Selection of appropriate, you can say, the remediation technique, like whether it is going to be one or it is going to be integrated technique by using the more than one techniques. So all these things are going to be taken into account for the sustainability of the groundwater resources. Indeed, we conventionally we take up these groundwater samples. Sometimes we in-situ treatment, you can say the measurement of the in-situ parameters. Sometimes we take in the lab for the detailed analysis of the water samples. So biomonitoring technique especially were very, very important. Biomonitoring means the site at large scale can give some indication that whether the site is contaminated by some pollutant or not. So such type of the indicators can tell us at a very early stage that the contaminants are released in our, you can say, soil water system, whether it is aquifer or soil water sources. So if we can take the actions at very early stage by using the this biomonitoring as well as the conventional physicochemical method where we do the grab the samples and analyze the samples, in that case we can save a lot of efforts as well as we can you can say implement such type of the effective techniques into the polluted sites. So these are the things which we have developed and which has been also published, and yeah, I think time is very limited. I will not be able to go in very detailed. So I was running like a super fast train. So excuse me for that one. Yeah, thank you. Thank you, sir.
Thank you so much, Professor Dr. Vijay Yadav, for your informative presentation about groundwater management. So without any further delay, we would like to hand over the first.
Okay, thanks. So you take program with that. Stop. That's good. No, a little bit. Oh, thank you.
Thank you so much. Thank you, sir. Now, our fifth presenter is Dr. Saroj Adhikari, from postdoctoral researcher from Cheong'an University of Technology, Taiwan.
Yes.
Right.
Okay, good afternoon. Thank you, Dr. Chan, as chair of the session. Before I begin with the presentation, I would like to have a disclaimer, because as an environmental engineer, I will try to drive you slightly off-road. But at the same time, I'll be very careful not to veer off my vehicle. So, because most of the presentations, like as the symposium focuses on AAAE, climate change and agriculture, I'll be talking about drinking water now. So you have heard a lot about irrigation, groundwater, recently groundwater, and a lot of issues on irrigation water. But now when I talk about safe water, and basically I would like to focus when safe water is not safe, through a case study that investigated the lead and nickel contamination in point of use water dispensers. But I'll try to relate in a larger scale, like how does this study relate to a broader theme of climate change and to some extent the food safety in the later stages after we drink the water. So to begin with, safe drinking water, if we talk about the drinking water and its local perception, it varies among the countries. In some countries, we regard tap water as drinking water, whereas if you take the example of some modern Asian cities, they consider point of use water dispensers as a main source of drinking water instead of tap water, like cases of Taiwan or Japan or some cases of South Korea. But if you look at Singapore, they still consider faucet water as drinking water. And so now let's look at Buoyant drinking water. I wanted to introduce my first slide as a hook slide. So now I'll take you to the broader perspective of going beyond the drinking water. My system is here. I would like to begin with climatic stresses that have impact on the water system in terms of water scarcity or quality deterioration and infrastructure stress. That leads to the growing reliance of the community on decentralized point of view systems. One of the several causes of the dependence of people on point of view system is the climate that causes the stresses. So one of the causes is climate change. So when we have the point of view water system and we consume the water dispensed by the system, human health is one of the direct connections, no doubt. It depends on the quality of the water that is dispensed. But if you go beyond that, the human health and the human population, they will have relation to the food system in terms of food safety, agricultural productivity, and rural livelihood. So the drinking water that I'm talking here in AAAE is not just drinking water. It's about climate resilient water and food systems in a larger scale. So climate change increases risk to water quality. Communities rely on pure water dispensers, and safe water is essential for health, food safety, and climate resilient agriculture. But now the question comes, are these systems that we rely delivering safe water? If not, this part will be affected. So that comes to agriculture and human health. So with this interrogation in our mind, we did some investigations in Taiwan based on the elementary schools, the water that is dispensed by point of use dispensers. In elementary school, because the younger children, they are at the high risk of these heavy metals, lead and nickel. So we found, like, you see, for nickel, there is accidents in 8% of the school, accidents to the WHO guideline value. 7% is for lead. And then we did this in our university campus. Like we investigated the entire campus, collected the drinking water from faucet as well as the dispenser. And then we saw the incidences of higher lead contamination here as well. So these have been published in different journals in different years. And then with this problem identification, what did we do is, like, we defined our research approach. As an environmental scientist or an environmental engineer, what do? Like, we identify the problem, we explore the causes, and also propose the solutions. So basically, we are driven by evidence, guided by evidence, and driven by impact. This is how we define our research approach to contribute to the society and community. This is a part that we were discussing during lunch. And then following this, now once we have the cases of lead and nickel contamination, then we have a question like, where does it come from? Where does that lead and nickel in drinking water come from? So one of the possibilities would be distribution system, the water that is distributed from treatment to every household, or plumbing materials. We use different type of plumbing materials like lead, copper, stainless steel, or PVC system in Nepal. But why these both are unlikely in Taiwan is because lead pipes are banned in Taiwan. So the previous source of lead is a question, where does it come from? And stainless steel pipes, they are considered corrosion resistant. If so, where does the nickel come from? That was reported in our study. So with this, then we thought of like, broadly we thought like, if these are not sources, so these metals should be coming from the dispensers alone. Because a point of use dispenser has several components within it. So different components might be, acting as a source instead of controlling the relays. So this is what we thought of. And then with this question, what did we do is like we set up the point of use system. We simulated in our laboratory. Like we brought the different models of the dispenser that are distributed in Taiwan, commonly distributed in Taiwan. And like you can see the different models here that comes with 3 taps, hot, or cold, and warm, and some other, they have a single system of the dispensing system. So we purchased this from the company, and then what we do is like we set up the sampling points by ourselves, post filtration, storage, and then transfer. Representing the different unit, we set up the sampling points to see which part contributes to those metal released that we recorded in our earlier studies. And then this is our key finding. This is what we need to note here is like when we feed the input water, that was clean water, we synthesize the tap water by ourselves and we fed into the dispenser components. And this was clean water. There was no lead and nickel added on it. But when we sampled from the different units, like I discussed before, 5 units, we found the traces of lead and nickel. So if your supply water doesn't have lead and nickel, but your water, that drinking water contains the traces, it gives us an idea like this should be coming out from the dispenser system itself. One of the hints that we got. And then what we did, like doing alone would not give us a better picture of the science behind it. So what did we do is like we spiked our samples. The WHO standard for lead is 10 ppb and for nickel is 20 ppb. So we put this amount of lead and nickel in our system, and we wanted to see whether our dispenser will have some control on it, it will reduce or not. But what was our observation? The lead was not exceeded. So the filtration system worked well within the dispenser system. But in the case of nickel, there was 28% exceedances. So when we are saying drinking point of use water dispenser as water as safe water, that might not always be true. And then sometimes it's not only the case of the regular water quality parameters. So what did we do is like if there is a typhoon event that brings in more salinity into the water supply that is supplied to the drinking water in regions like Taiwan or in Japan, then we spiked our sample to a very high concentration to represent the worst case scenario that sometimes happens during the summer when we have typhoon events. So what did we do is like we spiked our water to 100 ppb of lead and nickel. And then we checked that in that case, the lead exceedance was 4% and nickel was 5%. I'm not sure if I'm on time because I didn't hear any bell.
No, baby.
Okay. And then if this is the case, the 4% lead and 5% nickel and 28% nickel exceedance, where do these elements come into our drinking water? The distribution system is not the source we have already mentioned. The plumbing materials are not. So where does it come from? It comes from within the water that we are considering as safe water. So what could be the sources? Basically, in the POU system, they use stainless steel as reservoir. And stainless steel has nickel as one of the key components, in addition to iron and chromium. So this part of exceedance for the nickel that we are observing, it is from here, from the stainless steel reservoir that is being used in the stainless in the POU water system. And the lead, like they use the lead solder to connect the valves or the connection pipes in the stainless steel system. Although it is banned, but like in a larger scale use of the plumbing materials and the joints are banned. But still, when we connect something, we basically use the lead solder. So from the very small component, that lead solder, the lead is being contributed into our drinking water. So, and then we look at the performance versus risk. Like there are green parts, there are heavy metal removal. We saw some instances. Water accessibility is improved, no doubt. widely trusted system by people basically in the modern cities. But if you look at the risk, there are observed incidences as I presented before, contamination source, basically the internal contamination source. And we also looked at the effect of temperature, and we found like when the temperature increases, leaching is higher. So when we dispense hot water from the dispenser, chances of contamination would be higher because higher temperature would, facilitate the metal leaching from those components. So point of use dispenser systems, they are not failure, but also not fail-safe. This is what we found through our investigation. And then now is the time to rethink the last meter of water safety. Basically, when it comes to water safety, we think of once the water is treated well in the treatment system, we get safe water in our tap. But that's not always true. What happens is water safety does not end at treatment. It ends at the point of use. So this is the message I want to deliver when it comes to drinking water that we have been depending. So we monitor the point of use system, reevaluate the material safety, and integrate these into water safety policies. So if you narrow down the approach of my study, it would basically be related to water, drinking water, and human health. But like I said before, this all would be essential for climate resilient water and food system, from climatic stress, impact, human health to food system. So let's rethink the last meter of water safety. So before I conclude, I want to acknowledge AAAE, Professor Conwar for providing this opportunity, TSA Thailand, Nepalese Society of Agricultural Engineering, Indian Society and Agritechnica Asia for providing this platform to meet the scientists all over the world. Thank you very much.
Thank you so much, Dr. Salwas, for such a wonderful presentation about water safety and relating water stress, climate change. I want to relate to the theme, but no, that's where my expertise comes. Water is important. Water is important. Well, that's one.
To make sure that farmers are safe by drinking, so important.
Now, our next presenter is Professor Dr. Ramesh Kanwar, Distinguished Professor, UI State University, USA.
Did something down here. Good afternoon. I won't take much time. I won't use even 10 minutes. The purpose of my talk is going to be very simple. I'm not going to discuss much about climate change. I think I have to be at the podium because there are some online listeners. So sorry. I think everything you need to know about the climate, what climate change is doing, is already has said this morning. Whether it's a temperature increase might bring some plant diseases, might bring flooding in some areas, drought in other areas, more frequent rains. Those are kind of things that are happening. But water scarcity is an issue all over the world. It's not only Asia, but Asia does have very severe challenges. Reason is very large in Asia compared to the rest of the world. And right now we are talking about 2.6 billion people, but by the year 2050, there will be like more than half of the population in Asia, and we have to make sure that they are fully fed. And there is a typo there. It's not use of inefficient kind of water management practices. And we can blame anybody, but I think there are constraints. It's not a failure of the local governments, the country governments. I won't say that. It is essential that we address some problems. And some major interventions are needed. So I will give an example how we are doing things in the US, but the US model you cannot bring to Asia, to be very honest. We have to invent our own models or we have to learn from our own experiences. This is a map which tells the water stressed areas in Asia. Look at India, look at China. I have traveled in China. 2/3 of China is desert. But this map shows China is not water stressed. So I will question some of the maps which are out there available on the Google. Whatever data is available on the Google, who puts the data? Challenge that data set. Sometimes we have humanity happiness index. There's a human kind of unhappiness index. Who prepares these maps and who puts on the Google? So I think if you're working with students, ask the students, look into those. But innovative policies are needed. And what are on the basis of the lessons we have learned? Policies, I think Dr. Rajput showed some of the very innovative, thousands years old water harvesting techniques which have been practiced in Asia. I don't know how many of you spend lots of time in the Agritechnia exhibition. Lots of technologies are kind of displayed here on micro irrigation systems, affordable. And many of them are coming from China here. So I think that is another thing. And the government programs for water saving practices, like we had a project USAID in India, we had in Uzbekistan. In India, we were getting 60 to 80% subsidy the government was giving for farmers to implement or adopt drip irrigation systems. So those people might call subsidies, and some governments in the Western country might say bad policies, but I think those are good policies for the local people. So I think about that part. So I'm going to talk about soil moisture, what kind of farming system we have where we can preserve the soil moisture. And did I use last one? Zero tolerance for bad actors. Okay, what does that mean? So there might be some farmers who are not doing the right job, and they are not the role model farmers for the other larger community. So that's what I meant. In the US, the bad farmers are not considered really good ones. This is the message I want to give through my presentation. I don't know if many of you know. In the US, we have what we call check-off dollars. Every time farmer has to sell grain in the market, there's a legislation by the legislation has a kind of created commodity groups. Commodity groups can pick up a 0.1 to 0.05 or sometimes 0.2%, maximum 0.5% of the product sold. It comes to a commodity group. So commodity group can use that money to incentivize farmers. Mostly it is being used to educate, research, and marketing. And in India, the system is the mandi system. I heard that when farmers go, sometimes they lose 20% of the total product in the mandi business. So basically, the check-off dollars in India could be up to 20% compared to US, like 0.1%. So these check-off dollars we are using in the US for primarily the education. So one of my students, last semester he was taking my class, he's proposing check-off dollars for farmers who are mitigating carbon emissions by using best practices. And this is a new concept. Paper is going to get published soon, and it is going to create a kind of turbulence. Then the state legislature will have to debate, is it a good thing or bad thing? So the proposal is going to be that some of these commodity groups can use some of the current mechanism to reward or mitigate climate change. So I'm going to take you through pictures. I have played a role. I've worked for 45 years at Iowa State University. So these are the system. I was part of the puzzle. We have a big team, agronomists, economists, entomologists, plant pathologists. But without engineering, you cannot have a farming system these days. So look at the machine systems. You need right planters. You need right harvesters. And you need to make sure the soil is healthy. So this is a no-till system. There's another production system there, which we call reduced tillage. In Iowa, we don't move the soil because we don't have much soil. It's only like 6 to 8 inches left. If you level it, Some areas won't have a soil at all. So look at this complex system, how we are going to, how farmer might be farming, contouring and terracing. Not very easy with the machine systems. These terraces might be 20 acres, they might be 50 acres, they might be 10 acres. So there's a cost for the farmers to farm these terraces. So how you are going to reward these farmers if they are using carbon mitigation practices? Look at this system. Look at some of these systems. So the point is, some farmers are willing to adopt that practice, which will mitigate carbon emissions, which will increase carbon sequestration, which will reduce nitrogen leaching, which will increase soil moisture. So how to make these good farming actors, or I would say good farmers, and reward them. So the proposal is add another check of dollars, only 1% of the product, and prepare and reward these farmers so they become the extension agents for the other farmers. I think in the morning, Dr. Said asked a question, where are the extension people? Farmers themselves should become the extension agents. And there's another picture I'm showing you. And look at this landscape. It takes extra time for the farmers to plant. It takes extra time to harvest. It takes extra time to chemical application, other things. So this is the practice we had adopted, that you plant oats, you plant soybeans, you plant corn. Corn requires fertilizer. Soybean does not require nitrogen fertilizer. Oats you plant after the soybeans, rotate them, they don't need any fertilizer. So this kind of landscape will use only 1/3 of the land under fertilization. So these are the kind of practices we have proposed to the farmers. And then what we do, I had two water hydrology lab, I call it. These are field experiments. And so every planting system, farming system I showed you, we experiment it, we test it, and we see how much moisture they are preserving, how much nitrogen leaching they are reducing, and how much carbon. Basically, we are monitoring the carbon dioxide and nitrous oxide, those two gases. Which farming systems are reducing the carbon, what I call greenhouse gas emissions. So we do the minimum, our plot size is 1 acre. We are not using small plots. And we make sure that they're well instrumented to collect all the data. And you can be having small acres, small or big plots. And we do monitor the complete water cycle going from surface, different depths. These are the piezometers, and we look at the surface flow as well as the groundwater flow. And as well as the surface drainage. In Iowa, at a depth of about 8 feet, we have an impervious layer, just like a cement. So water table stands all the time. So we have to drain those lands artificially. So the message is reward those farmers who are utilizing the best water saving practices with check of dollars. And rewarding is not that give them $10, $20. Give them enough money, they can buy the equipment, which could be $100,000, and they can practice on their farms, and neighbors can learn, and the message spreads much louder. And the local and federal government can also develop similar practices. And this is the model we are going to propose in Iowa and see what happens if. The second thing is the trade, which is another message I want to give. Let's say, for example, hypothetically, Thailand is a water surplus country. They can produce all the rice. Uzbekistan is a water stress country. They can develop a kind of mechanism of trade that Uzbekistan does not have to grow rice at all. Now, will those practices work? Within India, it's not working. Punjab should not be growing rice. And look at the amount of water they're wasting, the rice they're growing. So within a country, at least they can do it. So the trade could be utilized as a best climate mitigation practice if it works right. And that's all my messages. Thank you so much. And so commodities can move from water stress areas to water surplus areas. Thank you so much.
Any question?
In India, where people will farm small and modular.
I think things can be done. Punjab is a good example. Every time I go to Punjab, I tell the agriculture university, stop growing rice. But
That is not happening.
Exactly. The question is not small, but still large. Good solid policy that we need. Thank you.
Ready? 1, 2, 3, again, ready? 1, 2, 3.
And our last presenter in this session is former Dean ACRI, Dr. P.P. Mahendran, Madurai, TNAU, India.
Yes. Good afternoon, everyone. Really, I'm extremely happy to present my keynote address in this prestigious international conference. And we know climate change has emerged as one of the greatest challenges in global agriculture, particularly in Asia, where the food security and farmers' livelihood are highly vulnerable, mainly due to rising temperature, changing precipitation, land deterioration, and the soil health related problems. So in this context, the soil organic carbon has received the scientists across the different nations because it gives a lot of benefits, not only to the soil, but also it increases the crop productivity. So with this background, I am happy to present this topic on soil organic carbon, a key to address soil health and sustain the food security under changing climate. So let me explain how the climate change influences the soil health and crop productivity. And we have the extreme climatic components like extreme heat, heavy rainfall, and drought. If we take heat, the extreme heat may reduce the soil health and also reduce the crop yield up to 20%. The extreme heat may reduce the, plant growth, and also it has a considerable influence on microbial populations. So similarly, the heavy rainfall. So heavy rainfall also leads to the reduction in yield to the tune of 15 to 30%. And besides that, the excess rainfall may cause the leaching of valuable nutrients from the soil system, lodging of the plants, and it also disturbs the soil and leads to lodging of plants. So all these factors are contributing for the reduction in the yield of crops. Then similarly, drought is the another extreme, climatic component. It reduces the yield even up to 60% because of wilting of plant and poor grain filling. So in short, I can say the small increase of temperature from 1.5 to 2 degrees centigrade, it may have the great influence over the health of the soil and the crop productivity. And in the next important problem we are facing now is the soil degradation. So I would call it as the silent global crisis. And we know very well that only the limited portion of our earth crust is available for the cultivation of different agricultural crops. So of the total, land, the major share is taken away by the barren land and glaciers. Only limited portion of land is available for agriculture. And again, this land competes with, forestation and urbanization, other kind of land use changes. And if you see the land deterioration, so it is occurring across the continents, affecting both developing and developed countries. The major components of the soil degradation process are wind erosion, water erosion. So water erosion is mostly taking away not only the topsoil but also the valuable nutrients from the soil system. And the chemical deterioration and physical deterioration, all this, the land degradation process will lead to the loss of soil health and ultimately the crop productivity. And this is the slide highlighting how the soil organic carbon is crucial for soil health. And the soil is the largest terrestrial carbon sink, storing about 1,550 gigatons of carbon as soil organic carbon and 1,700 gigatons as carbonate as inorganic carbon. This means the soil holds 2 times more carbon than the atmosphere and 3 times more carbon than the vegetation. And if you see the carbon carrying capacity of different components, fossil fuel dominates here. And in the soil, the organic carbon is very important because the organic carbon in the soil system is manageable. Why we have to manage the soil organic carbon? Because if we maintain the soil organic carbon, it leads to the maintenance of health of soil and ultimately the crop productivity. And here, I want to highlight that the soil organic carbon is a dynamic one. It is not a static one. Then at the global scale, the organic carbon, the carbon, it moves from the biota, plants, vegetation and atmosphere. And due to various, the climatic phenomena like warming, then precipitation and increasing levels of carbon dioxide, so there will be a continuous loss of carbon in the form of carbon dioxide to the atmosphere, and it's a great loss. So what I want to convey here is, it's a dynamic process. So we have to give enough care to maintain the soil organic carbon so that we can maintain the soil health and ultimately the productivity of our soil. And if you see the soil organic carbon stock in India, the stock is approximately 22.72 gigatons. And if you go through the organic carbon status across Indian soils, and it varies from region to region. The area with the humid and forestry region may have a high amount of organic carbon. Similarly, the arid and intensively cultivated region may have the small amount of carbon, low level of carbon. So this area actually we have to concentrate to increase the health of the soil and ultimately the productivity of our the agricultural land. Then coming to soil carbon sequestration potential, in India, the soils are having the high potential for the carbon sequestration. If you see the restoration of degraded soil, if you go for the restoration of mainly the degraded soil, it can sequester carbon to the tune of 7.2 to 9.8. Then if you follow some sound agricultural management practices on degraded soil, then there is a possibility to sequester carbon from 5.5 to 6.7. And similarly, the sequestration of the secondary carbonates form the dominant portion. And similarly, in the eroded area, if you follow the management practices, then it is possible to store this much level of carbon. So altogether, by following certain management practices, so we have a large potential to sequester carbon. And why soil organic carbon in the soil has to be maintained. So these are the reasons. Role of soil organic carbon in the soil health, because the soil organic carbon maintains the physical health of the soil, chemical health, as well as the biological health of the soil. It takes care of nutrient cycling. It improves the structure of soil so that the carbon in the soil can be retained. Then it enhances the water holding capacity And the organic carbon is the main source of food for the microbial load. So it increases the microbial diversity. Then it gives carbon sequestration. Then pH buffering. Then it enhances the soil fertility and productivity. And disease suppression is also another important, aspect taken care of by the soil organic carbon. So all these, positive factors are contributing for the long-term soil health and sustainability. Then what are the reasons for the causes of soil organic carbon depletion from the soil system? The main reason is the intensive tillage. So most of the farmers are adopting the conventional tillage, following the intensive tillage, where the soils are being continuously tilled and it exposes the soil to the atmosphere, and thereby the carbon present in the soil system is escaping as the carbon dioxide. Then land use changes. Nowadays we are putting our land into different uses. This is also another reason for the loss of the soil organic carbon. Then residue banning. So most of the farmers in India, particularly in the northern part of India, the farmers are taking up this kind of practices just to have a subsequent crop. They are going for a residue banning. Residue banning is the another important reason for the loss of soil organic carbon from the soil system. Then overgrazing. So overgrazing leads to the exposure of land surface to the atmosphere, and it causes the loss of carbon dioxide to atmosphere. And erosion is the another important problem. So where the water erosion and wind erosion are causing the major loss of soil organic carbon. Then how to rebuild the organic carbon in the soil system? Just by adopting these the various management practices, so we can build soil organic carbon. So no-till farming. So just now our Dr. Kanwar sir explained the conservation tillage. So conservation farming, it has three important components. That is no-till farming and the cover crop rotation. These are the three components of the conservation agriculture. So just by adopting no-till farming, then retention of crop residues, then biochar. One of the speakers also mentioned about the significance of biochar in agriculture. Biochar is having high surface area, porous in nature, which retains not only the nutrients but also the water holding capacity is also increased. Then adoption of crop rotation, then effective use of fertilizers, particularly if you could use the balanced use of fertilizers along with the organic manure, there is every possibility to enhance the soil organic carbon. Then cover cropping is also having significance for the buildup of soil organic carbon. So by following these important strategies, we can build up soil organic carbon. So these are all the various management practices. Just for want of time, I'm skipping the slides. Yes, sir. Yes. It's not moving far. Okay, sir. So my conclusion is, so nowadays the climate change is the major problem, which deteriorates soil health and also the crop productivity. So soil organic carbon has been identified as a key indicator for the sustainable agriculture. So by adopting some, naturally management practices, so it is possible to maintain the soil organic carbon. Once you maintain the soil organic carbon, we can have the healthy soils. So healthy soils means healthy plants, healthy human life, and healthy planet. This is the message I wanted to convey. Thank you for the opportunity.
For your wonderful presentation of how I will do the organic carbon. Okay, good. Thank you. Now, 15 minutes.
Public way. In all the final season,
Thank you.
Very good. You finished the session 10 years earlier.
Very good.
The only one. You got the doctor, you made it not very not
What he can do the question.
It's not a light of writing.
The questions were not there, same topic. Other thing like.
I will tell I will eat and keep up. The keep and he see it is clear.
ใช่มาแล้วเหรอ
ส่งเข้าเมลอาจารย์
มันเปิดไม่ได้หรอกเขาต้องโหลดใส่เครื่องเขาเองมันติด
รู้สึกจะเปิดจากนี้ก็ไม่ได้
มันติดสิทธิ์เข้าถึงค่ะเข้าไม่ได้ก็เจ้าของเขาไม่ได้ให้สิทธิ์มามันเปิดใช่หรอคนที่เปิดได้คือคนที่เขาส่งเองให้โดยตรงอันนี้ยังไงแต่ว่าเราต้องดูไต้หวัน
Yes, it was very true. So that's the right. The agency
ไม่รู้เดี๋ยวอาจารย์เพชรมาสอน
เปิดด้วยโน้ตบุ๊กตัวนี้ก็จะมีปัญหาเรื่องไฟล์เสียงที่ส่งต่อใช่ไหม
ที่เปิดได้เถอะเดี๋ยวกัดได้ ต้องนึกว่าของที่นี่ เรียกว่าไปก่อนเดี๋ยวแก้ Oh, your particular section. That's really interesting. ให้มือฝากไปถือเอาที่แล้วก็เอาไว้ดิบขอบเนาะอะไรวันตายเพราะว่าไฟอยู่ในโมเดลนะคะ
อันนี้คือถ้า
ตาก็เจอใช่
ให้คำถามตอนนี้จะให้แชร์อันนี้ใช่ไหม
ใช่
เพราะว่ามันเปิดแชร์เข้ามาอยู่ไม่ใช่
เดี๋ยวนี้ทหารทหารฉันบอกเอาไฟที่ได้ออกได้เลยใช่ไหมที่เราติดในคลิปไหม
คลิปเราตอนจบ
ที่เป็นลักษณะที่เป็นตั้งเป็นชื่อเดียวกัน
ส่วนเซสชั่น4ก็อยู่ในย้าย
ที่หนึ่งได้จีนอาจารย์คิดว่าคิดเนี่ยคิดที่มันก็เออ
ที่อย่างนี้เนาะนี่ครับพี่แล้วยังไงครับ
ทดสอบความรักกันเลยหน้าจอ
Feedback for everyone. Đểเขารู้เลยออยนี้เราให้นายกเจอเขาต้องแบบนี้เขาจะว่าคือ
Okay, give me some basic principles. What do I do? Oh, do we have all of them? I'm not sure.
I think all of them.
I just want to make it out there very quickly. Okay. And then we'll start at yes. Yes.
Yes, yes.
Now it's my time. I was finishing by 5. I think we can do it.
Yeah, yeah.
I am ready. Since I've always my dessert, so I'll just do this here after 10 minutes. I'm speaking. I have to give you time to so you are the first one. Yes. And request to have what is it? Don't disturb this one. Yeah. Maybe new one. Yeah, what do I do? So I can write my name. Yes. Yeah, right. And you can announce my name also. So Shield, right? Oh, this is not yours? No, this is my supervisor. He is absent, so I am presenting on his behalf. Oh, okay. Yeah. Okay. My slide is very less. Okay, we'll start the last session in 1 minute. So maybe it's good if you could take your seat. Our speaker.
Announcement. Okay, before we start again, can we go back? Pete, check up. Just in case you didn't see this, please note that the Thai Society of Agricultural Engineering will hold a meeting, international conference in Taiwan in September. So for any one of you who haven't picked this up, please feel free to capture this, and don't worry about the due date, okay? Because here we put the due date as May 31st, but we will extend it for a month. Yeah, we're gonna extend it for a month. So you have time, you still have time until the end of June, okay? So please, yes, please.
How to become member of Thai Society of Agriculture?
We can apply. I think.
Okay. I think are you done? Right. So we can go out to time.
Yeah. We come back to that, please.
All right. Thank you very much, Dr. Shankar. Will start now.
Good afternoon, everyone. Myself, Dr. Shivankar Demnath. So I am here presenting our project work on strengthening climate resilience in Greater Mekong sub-regions through a digital agro-meteorological forecast and advisory systems. So let's focus on the challenges in our study regions. So that is Greater Mekong sub-regions. So in these regions, the smallholder farmers basically face the challenges due to climate change impacts, and as a result, their crop fail and they get the reduced crop yield. And in that region, there is another challenges is that there is limitations in accessing timely, accurate, and actionable meteorological information, which is required to implement climate smart agriculture nowadays. Though there are lots of farmers use enough number of mobile handsets, but there is still scope exists to introduce digital tools to support climate smart agriculture. So prior to this project, we started one baseline survey, and we found that the farmers are dissatisfied with existing weather and climate information systems. So to address these challenges, we propose the solutions. So that is our hello. So that is market ready digital technology AFS. So what AFS stands for? So AFS stands for agrometeorology forecast and advisory systems. So these systems considers state of arts of existing weather and climate forecast to implement agronomic decisions to the farmers. So these systems considers reliable agronomic advisories algorithms with respect to specific crops, and this techniques. So there is a feature in which the farmers can communicate themselves. So let's look into the objectives of this project. So first objective is to deploy fully operational agrometeorological forecast and agronomic advisory systems. The second one is improve adaptive capacity and decision-making powers of smallholders and agri-businesses in climate-smart agriculture. Third objective is document and demonstrate challenges, opportunities, lesson learned through this project, that is agrometeorological forecasting and agronomic advisory systems. And final one is document suitable business models for the FS system. So the project is implemented in the Greater Mekong region. So this is the total Greater Mekong regions, and we focused these two regions. One is Thailand, another one is Vietnam. In Thailand, we focused on Nakhon Phanom province, and in Vietnam, we focused on Can Tho. So in this project, before starting, we did baseline survey of 150 farmers, 84 from Thailand, 66 from Vietnam's, and from that feedback from baseline survey, we developed our model, that is the app. The name of this app is Climate Farm app. After developing this app, we gave hands-on training to the farmers. Farmers use this app, and after that, we arranged demonstration workshops. And finally, we conduct that inline survey considering 180 farmers. So in these projects, the stakeholders included smallholder farmers, youth farmers, women and women unions, agri businesses, and different government agencies. So these are some pictures taken during the baseline survey to identify what is the farmer's priority requirement in that region. So let's focus on this Climate Farm applications or mobile app we develop in this project. So the key features of this mobile app is the facility of multi-language. So here you can see the screenshots of our app. One is in English, Vietnamese, and Thai. This app provides localized forecasting information. So here is some screenshot, also provides what is the forecast. For example, here it shows prepare for possible heavy rains in the coming 3 days. So this type of localized forecasting facility is available. And based on the forecasting, it also provides specific advisories. And if there is any extreme weather event upcoming, it gives the notification. And farmers community can interact among themselves also. So this is the home page of this app when we open the app, and using this other app, we need to log in this app using our mobile number, mail ID, and passwords. So let's have a look on the key findings from this project. So in this project, one of the key findings is development of mobile app and deployments. So once the login is successful, then this page you can find. So in this first option, if we click or touch, we will get all the notifications or all the advices. So advices looks like this, announcement and all these things. So the second option shows the forecasting. So in this icon, basically the farmers can give their experience, means it's farmer forecasting. means farmers can give input what he thinks about tomorrow or next 2 days. For example, here we can see when farmers want to touch here, this example comes, of course, exam question comes. So first question is, how do you predict temperature for tomorrow? Is it below average, average, or above average? So farmers can give the feedback in this app, and based on farmers' feedback here, the algorithm will recalibrate to get more accuracy. So, and next one is the support. So if the users or farmers is facing any difficulty, so he can write here, and the developer will get the message, and he will solve this issue very soon. And next option is the community. So here the farmers can share their experience using these apps, photos, videos of their field, and anything they can post these options. So these apps is available in both Android and iOS system. What? Can you see? Yeah, it's good. Yeah, yes. So second key feature is social media integration. So in this app, that community forum considers two groups in the Line and Jealous. Looks like the similar like Facebook's. Next finding is we organized the farmers training to give hands-on of this app, how to use this app. And next findings, these projects engaged 8 agri-businesses from Nakhon Phanom province, 2 agri-businesses from Vietnam, and 2 youth farmers groups. So here are the list of all the agri-businesses. It is seen that in respect to adoption of this app, so there is a increased women participation in this app, and the users mainly use 5 to 10 minutes daily in this app for their decision makings. So these are some photos taken from the app that farmers shared their feedbacks, their fields photos with other farmers through this app. Yeah, this project work supported 2 master students whose research is directly contributed in project scientific outputs. One is Miss Kathleen, and second one is Mr. Marco. And we prepared 3 manuscripts from this project, and all 3 manuscripts is under review. So there is exciting opportunity for scaling this weather climate information systems. We can consider the hybrid forecast models. We can redesign this user interface to minimize the technical jargon. There is a strong demand. We can integrate the crop price in this app. And we are working on this implementing offline access, so farmers can use this app in offline if there is an unstable internet. So here is the conclusions. So 85% of our user is expressed willingness to recommend this Climate Farm app for their work. And we recommend 3 policies. One is government must prioritize investment in rural digital infrastructure. Digital advisory tools should be formally integrated with national agriculture extension programs. And third one is adopt a co-production approach in technology designs. So this is our future works. That is the advanced works of our this project FS. So here we proposed climate model-based decision support systems, which we are going to implement in Lao period. Thank you.
Question for Dr. Okay. All right, our next speaker, okay.
Yes.
Number two.
Thank you. Can you change this? Can you change this?
He's doing it. Can you?
Okay.
Hi.
Very good afternoon, chairperson and co-chairperson, and the professor, Dr. Kanwar, Dr. Kumar sir, Dr. Raja, and Dr. Syed sir, and my good friends. Good afternoon, everyone. I am presenting the how the changes in the climate is occurs. How to protect or how to prevent these changes to normalize the system, ecosystem. So normally any industry is established. Naturally, it may develop some pollutants. It may create some pollutants. It may lead to the degradation in the soil, water, thereby ultimately the changes in the climate scenario will occur. Under the situations in government of Tamil Nadu in South India, they established a paperboard industry affluence in the former Chief Minister's constituency, Madam Jayalalitha constituency. They established the paperboard industry affluence in 2015. But by the government, that is Tamil Nadu Newsprint and Paper Limited organization, that is a government of Tamil Nadu industry, that is an organization. But everyone knows that already there is a paperboard industry exists in another place that is called Karur district in Pugalur. But this industry has been established in the CM constituency. But before starting the industry, the government assigned the university to what is the current status of soil health and groundwater quality, whether this industry in future is going to affect this groundwater or the soil quality. Such situations, the assignment given to the Tamil Nadu Agriculture University, when I was head of the department and chief scientist on I3 point salt affected soil, that CSRI Karnal, we have taken this assignment. We have started working on this in area where the industry is going to establish. So based on that results, for the past 10 years, from 2015, this industry was started. 16, it was started. Then before starting the industry, we have assessed the groundwater quality and soil health. And now we also assess the groundwater quality and soil health. We are continuously monitoring those areas, how it can be protected from the degradation or deterioration. So, next, please. Yeah. So to pulp and paper, just now I just told that pulp and paper industry is classified as a red category in highly polluting industry in India. The more than 250 chemical compounds are generated, and these industries generate 75 to 225 that is a meter cube wastewater containing high BOD and COD, and the properly treated effluents can be reused in alternate irrigation source supplying water and nutrients. Nowadays, treated water is considered as the potential water and nutrient resources, and hence the use of wastewater in agriculture gaining momentum. Yeah. To effluent quality characterization, we have objectives we have framed for quality characterization of the effluent and the geo-reference to soil mapping for soil nutrient distribution across the 416 geo-reference sample, and the soil microbial population and groundwater quality monitoring and soil quality monitoring and crop cultivation under TN, that is treated paperboard industry effluent dilutions with organic emulsions for cotton, black gram and gingerly and better gram. It is continuing. So this is the site area where the industry has established in in Mondipatti village of Tiruchirappalli district. That is this is the Tiruchirappalli district where this is a factory area. This is a plantation area where before starting the industry, we have assessed the groundwater quality and soil quality of these regions. The physicochemical properties of the paperboard industry effluents are, we have the pH is raw effluent and treated effluent. You can see raw effluent and treated effluent, and also easy electrical conductivity, that is dissolved, that is salt, and BOD, biological oxygen demand, and COD, and sodium adsorption ratio, and residual sodium carbonate, and soluble sodium percentage. These are all the raw effluent characterization. This is the treated effluent characterization. The groundwater quality of benchmark monitoring wells in TNPL Unit 2 in 2016 to 25. For last 10 years it was done. So originally we have identified 37 wells for assessing the groundwater quality, that is open wells as well as tube wells. Based on the characteristics of those wells water, we have identified the 18 wells for continuous monitoring of this over the period of time. So based on the GPS coordinates, we have recorded each sampling point and enabled the spatial analysis also. So subsequently, the impact of wastewater irrigation on water quality has been analyzed through periodic sample collection in 18 benchmark wells located around the factory. That is 5 kilometers around the factory. So this is the where we have some of the pictures where we've done the work in different places. That time as the chief scientist of ICR Agrip on salt affected soil, I was involved in this project. These are some of the photographs. These are the area where the sampling point. These are some of the sampling point. You can see the sampling point where we have collected, and pH of the water samples, and sodium adsorption ratio, residual sodium carbonate. I already given in table also it is there. You can see the different 18 benchmark wells. It is we have identified, and pH, EC, RSC, and ACR. We are continuously monitoring this. So when we see the results from 2016 to 25, we can see so almost all this SCR is permissive limit. The residual sodium carbonate, that is it creates a soil sodicity, that is alkalinity development soil. Almost it is not much variations or almost nil. So the EC also not much variations there. So little difference. You see 0.6 and 0.7. So it's not much variations. Then characteristics of leachate collected from piezometer. So we also collected installed piezometer in different locations, and we have collected samples from the piezometer, and we have analyzed all these parameters. Again, the groundwater quality monitoring wells. So the 10-year groundwater monitoring programs across the 18 wells have no evidence of quality deterioration. So there is no evidence of quality deterioration. That was the observations we assessed based on our quality well monitoring. This is the soil parameters we have collected in different locations to assess the side of it. I think our Dr. Raja is here. He was invited him as the expert for the soil profile description. That is the time when the project was ongoing. This is the different soil series we have identified around the paperboard industry affluence areas. See, these are all the different soil series. Say, long-term treated effluent irrigation substantially improved the soil quality. Instead of deterioration, it's improved soil quality because this contains a lot of organic matter. It contains a lot of organic matter. See, all the plantations. See, you can see all the plantations we have established in the paperboard industry area. All the leaves shed on the soil. See, originally it was a barren land. Shed on the soil enhanced the organic carbon content of the soil, and soil fertility was substantially improved. These are all the bulk density, and the soil available nutrients, and soil available potassium, and the soil microbial populations. You can see soil microbial population. Drastically, they improved the soil microbial populations almost all the plantations. Phosphatase activity and soil phosphate microbial population, and after that we have used this effluent for cultivating the crops. Whether we can use the effluent for cultivating the crops, because it contains a huge quantity of the nutrients. So we have cotton, black gram, gingerly, and cotton bitter gourd. There are 5 crops so far we have done at Didias and Tirchi. It's a bitter gourd variety. We have done it in the that is in the micro irrigation method, and different effluent 20% and 50-70%. Say Can see some of the photograph. The results of soilless culture, there was an increase in fruit weight because of the effluent irrigation. Similarly, then for the pot culture action marigold, we also observed same results from this marigold also. Then also for groundnut, we also treated with the effluent 70% recorded the highest pod yield in groundnut. For gingerly also 50% effluent recorded the highest grain seed yield. Then for cotton, so almost all the residual crops, we have got almost all the crops, we have got performance. You can see the performance gain of 15% and 21%, 19%, like that it is there. So we could able to get some good information from these findings. These are all the barren land. So originally when I was visiting this factory area, this was the land. But now we got this land like this with the plantations, huge plantations. So we made a green cover. The salient findings, so almost all the parameters consistently within the permissible limit as assessed as gone by the Tamil Nadu Pollution Control Board. There is no contamination of groundwater quality deterioration over the 18 benchmark over 10 years. So soil organic carbon has increased from 32 to 156% across all the 17 species. The microbial population enhanced, the cotton and black gram, all the crops we have enhanced, improved yield. The TNPL unit to represent the scalable evidence-based basic model. 9,000 meters cube, that is a meter cube per day water use for 650 acre of productive plantations, carbon sequestration and nutrient recycling, which was previously in barren situation. Thank you very much, sir. Thank you.
We have time. Any other one question, one or two?
On this side. So we can take a photograph of all of that. Thank you. Because we got this flower. Nice. Very nice. Yeah. Thank you. Thank you, sir. Thank you.
All right, who is our next presenter? Dr. Musami. Okay, very good. So we'll give you warning, and I think you have the time. Okay. Yeah.
So, no, yeah, it's the most respected organizing committee of this the greatest event, and the chair as well as co-chairpersons, then fellow scientists. Good evening to all. So here my topic is the aerobic rice protections to mitigate the climate change. So just here I'm standing before you to present my nearly 20 years of experience in aerobic rice production. So get into the introduction. So the global rice production challenges, okay, since the rice is consuming nearly 50% of the available fresh water, and of course it's going to be of course 50% of the food production and the national security as well as in Asia as well as Africa. Okay, so in general the traditional rice cultivation is done, or conventionally it is being practiced under puddled conditions, that is under continuous flooded conditions. Okay, so in future it's going to be a big threat with the climate change, because so here rice crop requires a high, or the footprint of the rice crop paddy is nearly 3,000 to 5,000 liters per kg of grain. Okay, so that means that the water requirement of rice is very, very high when compared to any other crops, say like crops like sugarcane or banana or even coconut. Okay, then so yeah, under puddled conditions, that is conventional rice productions threaten the atmosphere with a significant emission, that is methane emission. Okay, then of course the conventional or traditional rice production is highly vulnerable with the erratic rainfall figure. So these are the concerns that we are going to face in near future. Okay, then coming to impact of climate change with rice production. So the key impact Yeah, of course, the rising in temperature. I think Dr. Narendra Kumar has explained, focused about the rise in temperature and its impact on soybean and wheat. Okay, so the IPCC report says that if there is a 1 degree Celsius increase in temperature, so it will lead to 10% of the yield reduction with the rice. Okay, and of course for soybean, yeah, it's okay, but in case of a wheat, yeah, it will be more than 10%. Okay, then so frequent drought. So of course here just I want to emphasize on that. So of course the quantity of rainfall has not changed or it has not declined, but the distribution pattern has changed due to impact of climate change. Okay, yeah, of course rice production is going to face the consequence of erratic rainfall distribution. Then of course yeah, whenever there is a erratic or rise in temperature, yeah, we are going to face the threat with the pest and disease. Okay. Yeah, of course, the declining groundwater, yeah, because nearly 56% of the rice production is in India is solely depends on groundwater potential. Yeah, of course, the declining in the quality as well as quantity of the groundwater is going to be a major threat with the rice productivity. Then, of course, higher greenhouse emissions, that is methane, right? So this is in nutshell. So what happened? So whenever there is a temperature rise, or that is due to temperature stress, yeah. So it will affect the flowering, especially spikelet sterility, as well as it leads to poor grain quality. Then hydraulic insert, that means insufficient rainfall or erratic distribution of rainfall. So that is going to face or it leads to water shortages. Then importantly, the rise in temperature or the climate change is going to its own impact that some of the minor pests will become the major pest, especially in rice. Okay, so then not only pest and disease also. Then yeah, emission. So that is the major challenges with the climate change, right? Then so coming to concept of rice production system, that is aerobic rice production. So aerobic rice is a cultivation system in which so rice is grown in well drained aerobic conditions. So it's not puddled or it is unflooded condition. That is the first concept. Then rice is grown in well drained soil. So it's not a puddled or it is not a flooded condition, and there is no puddling. Yeah. Then continuous flooding is avoided. That means so here we are intended to raise the crop as that of any other ID crops like wheat or cotton or maize. Okay. Then irrigation water is applied as and when it's required, or you can say technically whenever, or you can say the irrigation soil moisture content will be raised near field capacity of the soil. Whatever may be the soil type, yeah, just will be aiming to maintain the moisture content at the field capacity. Then, yeah, here, so direct seeding is replacing with the conventional transplanting. So instead of nursery, puddling and everything. Okay. Then of course, so ultimately the system combines the advantage of both upland as well as the irrigated rice system. Okay. So that is the main concept of aerobic rice system. Yes. Then, so here just this slide shows or compare the difference between aerobic as well as a traditional rice production system. Land preparation, yeah, puddling, dry land condition, then crop establishment, it is transplanting, here it is direct seeded. Then importantly, water use, yeah, it is very, very high. So as that you know very well that the water recommended rice is 1200 to 1500 mm per hectare. Yeah, here it's going to be less. Then methane emission under puddle condition, that is traditional rice is high, here it is low. Then weed infestation, yeah. So here we have to accept one thing, whenever we are going for a direct seeding or whenever rice is being grown under direct seeded condition or aerated condition, yes, definitely that weed infestation will be going to move, or it's going to be a big threat in condition. Yeah, that is the main focus. Then labor requirement, yeah, it is high with the conventional system, whereas it is low. Then soil condition, it is here we are maintaining anaerobic condition. Here, the aerobic condition. Okay, so thereby we are reducing the methane emission. Okay, right. Then water productivity, it is low in traditional rice system, whereas it is very, very high in case of that. I'm going to explore with my own experience. Right. Yes. So this is the principles. That means non-puddle and non-dry land condition, then direct seeding, then maintenance of soil moisture near field capacity, then efficient irrigation method. So wherever possible or wherever the system permits, yes, you can try with even micro irrigation system. So we have started under the able guidance of my chairman. So during the year 2002 with the micro irrigation system, that is sprinkler irrigation system. Then use of drought tolerant varieties. So yeah, so all the released varieties may not be suitable for the anaerobic condition. Yeah, we have to identify, we have to develop high yielding as well as drought tolerant varieties. Then whenever we are converting the anaerobic into aerobic condition, weed infestation going to be a major threat. Yes, then we have to develop the integrated weed as well as the nutrient management strategies for aerobic rice production. So this is the agronomic management technology that we have evolved. First one is dry tillage, then drought tolerant varieties, then direct seeding. This is the actual seed rate, that is 25 to 30 kg is enough per hectare. Then irrigation management, field capacity at 50% or 60% depletion level. Then nutrient management. So this is the actual recommendation. That's also in case of NPK for aerobic rice production system. Then of course integrated pest and disease management. So coming to variety, these are the varieties which is evolved and released in India. So if you see the average potential of the yield potential of the variety, it will be varying nearly to 3.75 to 4.5 tons per hectare. Okay. Then so the varietal selection, especially for in India. So this is the first variety released from IRRI. Okay, which is having the drought tolerant ability as well as a high water productivity. Then, so this is the first culture released from IRRI, which is having short duration and aerobic adaptation. Then this is the another drought tolerant high yielding variety, and this is the variety which is released from our own university. And the ADT 45, 43, and Anna 4. Right, so these are the varieties that we are recommending to aerobic condition. Then coming to water saving potential of aerobic rice, this is the extent by which you can save the irrigation water or the available water resources. Then so this is the experiment conducted by our colleague. So this is water use efficiency and water productivity of aerobic rice. So here, so you can observe. So the variety Anna 4 performed better with high density, or that is 25-10 centimeter spacing, right? So this is the my irrigation water management and the varietal performance under different conditions. So here you can say, so the PM MOS 9 in that 461 performed, so or gave the higher grain yield as well as water productivity when compared to any other variety. So this is the results from Kerala. And so reduces methane emission. So this is the extent. Okay, that means 80 to 90% of the methane emission can be reduced whenever you are converting anaerobic or conventional system into aerobic rice system, right? And of course, so there is a possibility of nitrous oxide emissions, because here just we are completely changing the scenario. That is we are changing the hydrodynamics mechanism with anaerobic conditions. So there is a possibility of a nitrogen emission, right? Yes, so this is this is the extent by which you can suppress the methane emission with the aerobic condition, right? So this is the yield performance. So far we have released so many developed varieties. So this is the average yield performance, or average yield that can be that we can expect, that is 3 to 5 tons per hectare. So if we are following, or the farmers are adopting improved management, yes, we can expect 6 to 7 tons per hectare. But so this is the yield under conventional system, that is 7 tons per hectare, right? So this is the grain yield, so that we have evolved, right? Then water use efficiency as well as water. So this is the performance of the first release variety from IRRI, that is APO 1, which is performing well even in Indian condition, right? Then so coming to economic features or advantage of aerobic system, labor cost reduction, then irrigation cost reduction. So by we can say 30 to 50% less water as well as energy for pumping of groundwater potential. Then we can say with land preparation, so especially puddling and nursery management. Then overall economic impact with the aerobic rice production is reduced input cost, higher net return, and sustainable profitability. Then so this is the yield potential. One of my PhD scholar has evolved the potential water use efficiency as well as the weed management strategy for aerobic rice under our condition. So this is the varietal performance under aerobic condition, especially under drip irrigation system. So here our idea is, so here just we want to reduce the water input, the major input with rice production system, as well as we want to apply the required quantity of nutrients at the right time, at right quantity. So that is the principles. Yeah, that is why we tried with the drip irrigation system. So here you can see the upper one, the variety released from Erie has performed well with high grain yield, harvest index, as well as grain as well as straw yield also in both the season. Then this is the water use efficiency and water productivity of the aerobic rice, that is upper one. Yeah, this is the another experiment. Here we have tried with the herbicide combination. Okay. Yeah, then so coming to concerns and as well as challenges in rice production, yeah, weed infestation will be high because we are just completely changing the dynamics. That is puddling to anaerobic to aerobic condition. Yeah, weed infestation will be there. Yes, nutrient deficiency. Yeah, we have observed nutrient deficiency, especially during the early vegetative stage of the rice production. That is 20 to 25 days, especially zinc and iron. Then lower yield. Yeah. So I can't say it's aerobic rice system is fetching a higher yield. Yeah, it is comparatively lower than the traditional production system. Then lack of varieties. So we have evolved. Okay, so many varieties, but still we require the high drought tolerant as well as high yielding potential with the pest and disease tolerance also. We have to evolve the varieties. Then soil moisture stress. Yeah, so of course even though we are following some advanced irrigation system, still we have to optimize the soil moisture status for each and every ecosystem. Okay, then of course we have witnessed nematode infestation also. So whenever you are converting, so these are the constraints. Yeah, so these are the future status. Okay. Yeah. Thank you. Thank you, sir.
We're good on time, so any question? One?
I would appreciate. I never expected you are so wonderful lady. Yesterday I was talking to you about IPL. You never showed me that you know so much about it. Really, thank you.
Next speaker, Dr. Kumar. Thanks.
So, respected chair and co-chairs and the participants, good afternoon. So, just I am presenting a mini review, maybe. Most of them will be supplementing many speakers, especially Dr. Kanwar's paper, as well as other presentation. It will be supplementing. So, let us see how it is. So, the topic is reshaping the Asian agriculture under climate change. So, what are all the strategies you can follow? Okay, so already it is known that the temperature, rising temperature, the rainfall variability, and also the extreme weather conditions. These are all the factors due to the climate change. It affects the Asian agriculture. And also particularly the Asian agriculture is very vulnerable because all these 3 points are taken in the larger context. Okay, so this is a miniature figure which will summarize all the key facts on the climate change in the Asian agriculture. So you can see that. So the map one will show what are all the rising temperature. That map 2 shows the rainfall variability within the Asia and also the extreme weather events. And so all these combination is making the very vulnerable to the agriculture. Okay, so coming specific to Asia, so the Southeast Asia, India, Vietnam, and the Southeast Asia are very much vulnerable for our climate change. Okay, what are all the strategies important? So it has to taken care of the rural livelihood as well as the global food chain. It has to be supply the global food supply. It has to satisfy the Asian people. Yeah. So you can see that. See the Southeast Asia, the major hubs for the rice and wheat, whereas the East Asia is the large scale production and modernization. Example, China, and the Southeast Asia is the global exporters. Vietnam and they are the global exporters. Okay, so coming still specific, so that if there is a climate change impact, then automatically, so you have the global rice production is to be affected, the global population support has to be impacted. So we have to be very careful in the major crop production area. We have to take the measures. Okay, see the Asia's shifting climatic frontiers. So the as we said already, the major factors are the rising temperature, the variability in monsoon, so that the rainfall is fluctuating, and particularly for the Himalayas, the glaciers retreat, and some cases the sea level rise also. Okay, so we have already talked about this. Okay, so we know that very well. The climate change will affect the crop productivity. So for that, we need to have a good crop selection. We need to have the soil moisture is available at all times, and the irrigation is supplied, as well as the pest and diseases are controlled. Okay, these are all some of the statistics I am going to skip. Yeah. Okay, coming to India. So you can see that what is due to the heat related, what is the yield decline, and also how it is affecting the monsoon variability due to the erratic rainfall patterns. Our Dr. Gurusamy has explained on this. So that will be it. Okay, so coming to Bangladesh. So you can see that due to this climate change, they are experiencing the 8 to 12% reduction, and they have the very vulnerable because of the coastal. Say Bangladesh, the coastal sea level rise will be affecting due to their climate change. So some of the regions I also mentioned. Okay, coming to China. So you can see that it is the very, very modernized agriculture followed by the China to combat our climate change. So they are the one following the resilient agriculture so that their food security is maintained. Okay, so this is a sea level rise because this is another effect because of the rising temperature as well as the salinity. So this is in the Vietnam. So you can see that the Mekong Delta is very much affected because of the climate change, and many international projects are going on to combat the climate change. Okay. One factor which we forgot is the impact on the livestock also. So we all worried about only on the crop productivity, water, but the climate change is going to affect the livestock. So because in Asian agriculture, these go together. Livestock and the food production go together. So we need to give some more importance to the livestock. What is the effect, those things on the, because for example, the milk yield. So those going to be affected. Okay. So similarly the other associated, because in Asia, that is why all the aquaculture and the fisheries, they are having the problem. Okay. So once if you are get affected, the socio-economic also will be going to be affected, because we are all the small farm holders. So our employment is going to affect, the food prices has to increase, and also the poverty level will be increasing. So the small holders are vulnerable because of the climate change. Okay, so what is the strategies you have to adopt? Climate smart agriculture. So improved rice techniques, for example, Arabic rice, soil nutrient management, and also precision agriculture, like the drip irrigation, like that. It depends upon the region to region. So now the buzzword climate smart agriculture. So what to do, because all these drones are coming, and it will be helping in finding out the area where it is problematic, and you can give this solution to those areas which are affected or which can be improved. Okay, these are all some of the policies which I am going to skip it because of time constraint. Okay, the future research. So resilient crop breeding, advanced climate modeling, precision agriculture, AI-based decision support, and sustainable irrigation innovation. So these are all the areas which we can work on the future, so that to give the food sustainability. Yeah, coming to that, the conclusion, so that the institutional support must be there, and the regional collaboration has to be there within the Asia to combat the climate change effects. Thank you. Huh?
Very good, remember animals. Nobody talks about animal housing in Asia. And I think it's pathetic. There's no engineer in animal housing. I've seen because of the book, there's no engineer. Structural engineers are not there. We have to work on it. Very good point. Thank you.
That's all right.
Our last speaker, Dr. Raj. It's 4:20. I think we'll finish hopefully by 4:30.
You have to go to that. I'll let open.
Yeah.
It's opening. Okay. Yeah. Esteemed Chair, Co-Chair, distinguished delegates, ladies and gentlemen, good evening. See sorry.
Okay. Yes. This is not his.
No, this is not the one. I hope my time not started. Hopefully.
I will give you your time.
Thank you. The first slide.
Yes.
First slide. I'll go from the first.
Yeah, all right. Okay. Let me start from the first slide. First one. No, material. Yeah, fine. Yeah, thank you. Sorry for the initial hiccup. Esteemed Chair, Co-Chair, distinguished delegates, ladies and gentlemen, good evening. And I am Dr. Raja from the Centurion University of Technology and Management, and formerly a principal scientist, soil science. Mainly, we are working on the climate change, and I worked mainly in the Nilgiris as well as the extreme area of Thar Desert. Also, I have seen all the climate changes in the area, also the central part of India, Nagpur. So, my 38 years of ICR experience, and these are some certain case studies of the DST, our DST project, which was submitted last year, the final report. So, we found certain agriculture management strategies and practices to reduce the carbon footprint. And I'll see this. Yeah. So I don't want to explain much on this. It's a global greenhouse gas emissions are dominated mainly by the energy sector, almost about 75%, followed by the agriculture industry, with CO2 contributing nearly about 74% of the total emission. And this is mainly the dominance of the energy sector is by far is the largest contributor to India's greenhouse gases emission, almost about 60 to 70% of the total inventory. And the secondary contributor will be the agriculture, that is from that 18% as per the, and 10 to 15% is a waste, which contributes to the smaller share of the 5 to 10%. So this main will be the energy sector, followed by the agriculture. So contribution of the agriculture, forestry, and other sectors. The total reported emissions amount to 6,522 metric ton of CO2, with the energy sector serving as the primary contributor. Other sector include your agriculture, forestry, and other land uses, almost about 9.3%. And then the wastage will be 2%. So, the agriculture, forestry, and land usage generate around 673 metric ton of the carbon dioxide in emissions, primarily driven by the agricultural soils and enteric fermentation. It also acts as a significant carbon sink. It removes 780 metric ton from the atmosphere, largely through the forest offsets, resulting in a net negative carbon footprint for this specific sector. See, this is one from our ISRO project. We have established that eco-variance tower at the mixed land use system in Nilgiris, temperate part of the Nilgiris. This is our research farm. You can see there. And see, now this is the 5th year of the results. So the consistently negative net ecosystem exchange values indicate the ecosystem act as a net carbon sink. And peak CO2 uptake occurs during the January and March, likely due to the favorable conditions and high photosynthetic activity. And net ecosystem exchange shift to near zero, positive during May and June in some years, that is in 2022, 24, and 25, suggesting temporary carbon source condition driven by the seasonal climate changes, increased respiration, and also the biogenic activity in the Western Ghats. So this again, this is that the next one, we also established that eco-variance ecosystem under the National Hydrology Project funded by ISRO, Ministry of Forest Resources through ISRO. This is over the tea plantation in Udayamandalam, Nilgiris. And our initial research source, it's tea plantation act as a very strong sink throughout the period. And minus 3.547 in March 2024, where relatively lower uptake occurs during the month of May and September. And the tea plantation, which occupy more than 70% of the cultivated lands of Nilgiris in the Western Ghats, act as a net ecosystem. So, which is very, very important to ameliorate the climate change and global warming in the highly fragile Nilgiri ecosystem.
Could you go now to the next slide, please?
Yeah. Yeah. So instead of see here, the CO2 emission also we have done through that portable CO2 analyzer from the different land uses in the Nilgiris, from like tea, eucalyptus, agriculture, shola, acacia, pine, mixed and grassland. CO2 emission from the soils of the grassland is very high, followed by the shola forest and then agriculture. It is only a soil CO2 emission. When you are measuring the carbon assimilation of that particular grassland, then that becomes a carbon CO2 sink to the atmospheric. The grassland proved to be a sink to the atmospheric CO2. So the soil CO2 emission activity is mainly influenced by the soil moisture and microbial activities. Though the results indicate the forest and agriculture soils are having the higher sea efflux, but overall canopy assimilation of CO2 is higher in the forest and grassland ecosystem. And therefore, the conversion of forest and grassland into agricultural land need to be prohibited with a strict policy implementation. So we also did the work on the life cycle assessment of the agricultural activities in the agriculture, forest, as well as the different vegetables we have done. And the carbon footprint varied across vegetables with the French beans with 0.6 kg and garlic with 0.53 kg of CO2 equivalent per kg, showing the highest emission, followed by the moderate levels in potato. And while cabbage recorded the lowest footprint, established tea plantation exhibited the latest carbon emission intensity overall, lower than all vegetable crops assessed, considering the input applications and yield levels of different crops. So here we have given the different, we have also the pathways we have given, how they have, starting from the farmyard manure, compost, how much it is contributing, nitrogen fertilizer, phosphorus fertilizers, potassium, insecticide, fungicides, and all those things. So carbon footprint assessment also we have calculated, and you can see that French beans, potato, beetroot, cabbage, and carrot, garlic. And the result shows that garlic and carrot showed the highest carbon footprint among crops, while tea plantations had the lowest, indicating that vegetable cultivation contributing to the major share of the total carbon dioxide emission in the Nilgiris. So high emissions vegetable crops require targeted mitigation through improved management. And also the balance between carbon input and output need to be optimized in crop production. That is our focus. You can see that total CO2 emission in tons for the carrot, potato, beetroot, cabbage, and all. And you can also see it is again due to that. And you can also see the different factor influencing the carbon footprint in the Nilgiris. You can fertilizers, fuel, and agrochemicals were identified as the major contributor to the you can see here the synthetic fertilizers, fuel, and fungicides are the major contributors, followed by the manure. And you can see that the principal component analysis also shows the synthetic fertilizers is a major one, followed by manures and fuel use. And you can see that reducing this reliance of high emission input through improved nutrient use efficiency and integrated pest management is essential, especially for the high input vegetable system, for effectively lowering your agriculture carbon footprint in the Nilgiris. So you can see the you can see the good agriculture practices, especially the cover crops which we have gone for. And that has reduced that carbon footprint. And especially you can go for when you are using the conventional fertilizers with RDF plus poultry manure of 30 ton per hectare, showing the higher emissions. Natural farming and soil mushroom spent mushroom compost based practices and biochar and split dose significantly reduces the CO2 equivalent emissions in both carrot and potato system. And adoption of the lower carbon practices such as split farmyard manure based nutrient management and spent mushroom compost and biochar use and natural farming can substantially mitigate the greenhouse gas emissions, making the vegetable production more climate resilient and economically sustainable in the Nilgiris ecosystem. So the next is you can see the promoting how we can promote the circular economy here. Yeah. So then the mushroom compost, then you can see we can use that wastage of this mushroom compost for the used for this fertilizer these vegetables, and that has substantially reduced your carbon emission. And you can see offsetting the carbon credit based on the emissions. You can see because of the less time limitations, I'm unable to go into the detail of it. But you can see the different combination of the cropping system with the things minimal input with no spent mushroom. And you can also while increasing the productivity by applying the biochar as well as the spent mushroom compost, you will be able to sustain the productivity while reducing the carbon emission also. Yeah, this is probably my last slide, so last but one. And you can see what are the 4R approach, as you all know, very familiarly know. But what we have done here in Nilgiris is we have quantified by doing the renewable energy. We will be able to reduce by 10.67%, 385 tons of carbon dioxide equivalent per hectare. Data-driven decision support system we did try to do. Then we will be able to reduce it, and then minimum tillage by around 2.4% and manure management by around 33%. That is almost level by manure. By properly managing your manure application, you can be able to do with a 33%, 11,908 tons of the CO2 we will be able to reduce in those areas, and even decreased bare fallow we are able to do 21.76%. That is almost around 7,852 tons of carbon dioxide per hectare. So this is by our practices. By our improved management, agriculture management practices, we are able to reduce it and quantified it. And that we are now going for more like automation and internet enabled, IoT enabled agriculture things in those areas. And also we have taken another, by seeing our work now that ISRO has given the phase 2, and which we have taken the other indico-variant system to the Eastern Ghats also. Here I'm just, you can go through this, but I wanted to say you the wide adoption, only 2 important points. Wider adoption and enriched compost of this best management practices in the vegetable system would mitigate around 16,313 tons of the carbon dioxide equivalent per hectare in the temperate Western Eastern Ghats. So our main focus to go for more and more afforestation program, and then to protect the grasslands, which are boon to us to ameliorate the global warming. We are all talking about that zero emission towards zero emission status by our Honorable Prime Minister, and also now India Government of India is developing, encouraging the natural farming system, and even without losing your crop production, you can be able to maintain you can sustain the climate smart agriculture. You can go for that. So this is the need of the hour. So this is what all about I can say. And lastly, I should thank the chairman for very gracious enough to give a little more time, also because I am the last speaker. And and also my our Thai Society of Agriculture Engineers for giving me this opportunity, and the Indian facilitators, Dr. Professor Kumar, Professor Syed, and of course Ramesh Kanwar is so with clinical precision of his mails and all, time to time encouraged us to come here. So thank you so much, and all my dear friends. So, and these are my team, and see target action to combat climate change and its effects.
And of course, that Raipur sir always.
We'll take photograph. Thank you.
Right, thank you very much. I think there's a closing remarks. Once you short, I will leave the floor to you. Dr.
Yes. Yeah. Now I would like to invite. Yes. Thank you. Invite Dr. Indramani in the name of the chair of AAAE to have some speech. Yeah, please. Yes. Okay. There are many ones.
Thank you very much. So, friends, we had a very, very fruitful day. And, I really thank all the keynote presenters, all the chairs. There have been, 4 sessions. All chairs manage the time very well. And we all know that very fruitful discussion. I always say the future agriculture is engineering agriculture. And Dr. Kanwar made in his presentation, if engineering is not there, there cannot be an agriculture. So that is one thing. And other message is that in 21st century, engineers must know biology and biologists must know engineering. This is another very important fact. If you are not knowing biology, if you are not knowing agriculture, you cannot do engineering of agriculture because you have to do engineering of agriculture. And I liked your presentation very well. The way you talked about soil dynamics. So, and this is the time to thank Professor Gajendra Singh and all other and attendees who were online and whole night. Professor Singh has been online. You all know that Professor Singh is founder president of AAAE. He has been president of ISAE and he is mentor for all of us. Thank you, sir. Thank you very much. And this once again, I thank you all for coming from different part of the world for this conference and giving your thoughts. It has been very, very enriching to all of us. From one another we have learned, and from industry to field, from academics to modeling, everything has been covered. And great, I really thank my friend from Malaysia. So you created a wonderful, that's what Professor Kanwar said, very enthusiasm. Professor Kanwar, thank you very much for taking this great responsibility. Madam, you have been a force and source of inspiration for AAA, for the whole agriculture engineering fraternity of the country, all the presidents who have participated from Society of Egg Engineer Society of Nepal, Egg Engineer Society of Thailand, and all other. My teacher, Dr. Rajput, is here. He always, he has been my teacher. They have participated. So thank you very much, safe journey back to your home. And all of you have done a wonderful, wonderful contribution to this conference. My only request is that all egg engineering societies of the world, of particularly Asian regions, should become consortia member of AAAE. And another request, which Professor Kanwar also made, that all of you and your friends should become life member of AAA. With these 2 requests, thank you very much once again. Thank you.
So I think that at first we have the spare video of Professor Gajendra Singh, but I can see that he is here. And do you know that he is in the USA? And this is the night time, and he still with us along our day, and he's along his night. So then I would like to ask him, Professor Gajendra Singh, to have a speech with us live. Please turn on.
Then we ask him.
Yeah, Professor, would you like to speech?
Play that first. Then we can ask.
Okay.
We'll go over.
Sound. Sound, please.
Unmute. Hello. You can unmute.
Wait.
Yeah, just recorded.
Yeah, that is recorded first.
He can speak live. He's there on live. Can you unmute him? Can allow him to speak? You can unmute yourself. Just a minute. He's there alive. He's talking to you.
He would like to live?
Yeah.
ให้เขาไลฟ์เลยค่ะ
Yeah, just.
ให้เขาพูดเลย
You come alive.
ให้เขาพูดเลย
Javed.
อันมิวให้
No, not she's carrying. No, leave it. It's put on it. No, not.
อ๋อ
No.
เขาจะพูดไลฟ์
ให้เขาพูดอะไรเป็นไม่ต้องเปิดเทป
เปลี่ยนแล้วค่ะ
Close this.
มันไม่เสร็จ
Okay. Can you hear me?
Yes. Please.
Hello.
Please, Professor Singh.
Yes. Good morning from California. Sawadee Krap. Namaste. Salamat Datang. Good evening, Bangkok. First, my sincere apology for not being with you all in person. I have kept in touch with many of you during the preparations of the symposium. On all counts, this symposium is a great success. Can you hear me?
Yes.
Okay. The efforts put in by Khundares, President TSAE and Vice President of AAAE, and Professor Ramesh Kanwar, Chief Editor of International Agriculture Engineering Journal, are highly praiseworthy, and they deserve major portion of credit for the success of this symposium. Support provided by Syed Ismail, Secretary General, and Dr. Indramani, President AAAE, Dr. Kumar Veluswamy, Secretary AAAE, are all praiseworthy. Real actors the event, the presenters, deserve the most applause for excellent presentations. Session chairs did a great job of managing time. The audience was wonderful, with patients listening and asking questions politely. They all deserve a big applause. And there are several people behind the scenes running and managing the systems. They all deserve recognition and appreciation. Overall, the symposium is a great success, bringing presenters and audience from many countries, truly reflecting the composition of AAAE. AAAE has come a long way by successfully organizing events like international conferences, symposia, publication of the international journal, and bringing people from academia, industry, and governments to one platform to provide technologies to farming communities in Asia. I would like to request all the people who are attending and their friends and colleagues and the people they know to become life members of AAAE. I also like to request the national societies in the region to become the member of AAAE consortium. Very soon, we will be announcing the AAAE awards, and I request members to apply for the awards. Looking forward to meeting most of you in Bali, Indonesia, during the International Agriculture Engineering Conference, IAEC 2026 in November this year. Thank you all. Once again, have a safe journey back home. And I'd like you to give a big clap for Kondares and Ramesh Kanwar, the team.
Thank
The
you.
team.
Thank you. Thank you, Professor Singh. And I think that we would like to give a big clap for him.
Big clap for all of us.
Yes.
Yeah.
Yes. So the last, I'm sorry that I have controlled the time for everybody. Maybe it's quite give the press of everybody. But anyway, I think that everybody can understand. And I'm very happy to even our hard work before, behind the scene and before this today. And anyway, today we are happy and very happy to have you here, all of us. So do you have anything to talk?
Okay, so that we can continue.
Yeah.
Bring all the stuff. They're there.
Okay.
Yeah. Ask them to come here so we can thank them.
Yes. Okay. Thank you. So and group photo. Yeah, we will have group photo. So please come together. Yes. ค่ะเดี๋ยวพี่แจกให้เขายืนแล้วเดี๋ยวพี่แจกโอเคค่ะ please
One significant cake and put on the.
yes yes บอยเป
คุ
ลี่ย
ณ
น
วิ
ฉาก
บูลย์
เป็นฉากไอ้นั่นน่ะ
I see วิบูลย์
please พี่
Yeah, I will do it.
เอาเป็นแบ็คกราวด์เป็นบอร์ดsmall backpack.
So one side fits all.
One side fits
Thank you so much. Yeah. Like here. No, it's very useful when you write something.
If I got left side, only right side.
So, okay, man,
Happy birthday, Carl.
yeah. They are the professor from.
I think you need to train Dr. Sai how to recruit professors. They are all professors.
Yes.
We all have them.
They are professors.
Yeah, we all have them.
You need to find them.
Yeah, I have. Yeah.
ยังไม่ได้ต้องเลย
Some mistake, it should be 2 words.
เท่ใส่ก็ขาว
Or extra, come down.
น้องมันดีเลยยังตัวปี
Young people who don't have any problem.
อาจารย์เข้ามา เขาจะเอาตรงนี้เขาจะเอาแบบนี้อาจารย์เข้ามา
Take from my.
1, 2, 3 Nice again. 1, 2, 3
I'm sure. What is going
One, two, three. Yes, 1, 2, 3.
Okay.
That's okay.
That's okay. Do that.
Yeah, I think.
One, two, three. Okay. One, two, three.
Well, thank you so much.
Whereas, without you, nothing would have happened. God bless you. Keep working like this. All right? Thank you.